I have 2 points, I can find a line. Alternatively, I can have what?
Gradient and 1 point.
All right. Now, let me show you how to find the gradient. I know this gradient. Find the gradient of PR. Now, this might be new to you, right? Gradient of PR. Do you know that gradient of PR is called rise and run? If you don't know, please tell me.
Yes,
Okay.
I know.
Okay, then tell me what's the rise and what's the run. So therefore, tell me the gradient. I mean, if you can do it yourself, just do it and then tell me the answer. If you cannot, please don't wait. Please tell me. And
I do. Okay.
Try a little bit, but don't wait too long. Don't wait too long. Andrew, how is it so far?
Yes, relatively easy. I can.
Oh, pretty easy. Good.
Pretty soon.
Good. Same thing, yeah. If you're ready, your class, just don't look at the Jamboard, write down, use a different color to correct, and then send it to me. Elliot, are you okay?
It's y2 minus y1 over x2 minus x1, right?
You are relying on formula. I don't mind. You are correct. But what is the answer?
5 over negative 3.
Okay, so negative 5 over 3, right?
Yeah.
Now, think carefully, yeah? Think carefully. You are a visual person. You are at your best if you use it, right? Okay. Believe it or not, some people don't like to analyze things visually. But if you don't have that problem, you should use it. Now, do you know what rise means? Rise simply means, I go up or go down, right? Vertically. Yes. And run simply means I run horizontally, right? Because nobody run vertically. People run horizontally. Now, you look at your result. You look at your result. What is the vertical distance between P and R? Think carefully. What is the vertical distance? If you find it difficult to see, I want to teach you. If you want to find the vertical distance like that, right? Do you concentrate on the y coordinate or the x coordinate?
The y.
Okay. Then the y will be 5 and 2, correct?
Yes.
Let's keep it clear. What's the vertical distance between P and R?
3.
Okay. But you put your rise as y. Correct or not?
Yeah.
Seems to make sense, right? Even though you quote the correct formula, by the way, that's why there's a danger in formula. The danger is in us, not in the formula. You quote the right formula. Now, the run simply is the horizontal distance. If you want to look at the run, you concentrate on the x-axis, x coordinate or y coordinate.
X.
And the x coordinate, the distance will be
5.
And yet, you put your run as 3. Let me repeat this one more time. Your formula is correct here. But how come you get the wrong answer? Shouldn't the answer be 3 over 5? And it will be minus because it's a dropping line. So that part is correct. Again, Elliot, yeah, I'm asking you to evaluate your answer visually. Which one makes more sense?
The second one.
You know why, yeah? Because there's no answer key, and I'm not saying that I'm correct. No, I'm saying that you know what is wrong. Do you know what happened? Do you know what's the mistake?
No, I don't.
I think you put the y2 minus y1 using the x. I think that's what happened. Correct or not? You look at your working. Even though the formula you say correctly, you end up using the x coordinate for the y. You reverse.
Yeah, I did.
I think your visual side should help you decide. You don't just rely on formula blindly because your formula is correct, your calculator is strong, but you're the one typing, you might type wrongly, so to speak. In this case, I believe you, so to speak, type wrongly. Okay. When in our tuition, I'll ask you to identify the gradient not by formula, but visually. Okay, that is part of the training. It will be very fast and very beneficial to us. It's not something that your teacher usually asks you to train. Your teacher will ask you to use the formula and use it correctly. Okay, I will teach you to use it visually. Okay. Yeah.
Yes.
Minus. By the way, any complaint with the minus?
No.
Okay, I know that this is minus because it's going down, right? This is going up. Now, I don't want this gradient. I want this gradient. Have your teacher teach you something like this? This is the gradient, I know. This is another gradient. They are 90 degrees to each other, right? Has your teacher teach you how to find the gradient which is 90 degrees to what you know?
I don't think so.
Extremely simple, okay? Extremely simple. I won't teach you the formula yet again. I won't. I will just show you how to do it, maybe kind of logically lah. So from the M of PQ, I want the M of QS. Okay, I want the M of QS. The M of QS is so simple. It's going to be equal to, look at what I do. This is what I do. What did I do? I reverse the fraction and I reverse the sign. That's how you get the gradient, which is 90 degrees to the gradient that you know. The formula your teacher will tell. Do you understand?
Yeah. Yes.
Look at this gradient. Isn't it positive, right? Positive, right? This is negative. This is positive. There you go. You flip the sign. This is 3 over 5, and this is 5 over 3, right? It's more slanted. It's more slanted lah, 5 over 3. That's just a few logic. The point is flip the fraction and flip the sign. Now, let's practice a little bit. Let's say I have one gradient. This gradient is half. The gradient I want to find is perpendicular to M1. So please tell me, what is gradient to?
-2 over 1.
Yes. That's it. Not teaching you the formula, but you will be correct if you do it that way. Understand?
Yes.
Now, I ask you now, please find the equation of QS. Please do it yourself, yeah?
Yeah.
Me when you're done. Andrew, are you okay? Andrew, if you're doing it, just send me later, okay? After you.
Yes, I'm sending the photo right now.
Oh yeah, please. Okay.
Sorry.
If you are done, please send me.
Yeah, sorry, I have to get screen time.
All right. Oh. Right. Okay.
What does it mean by find equation of Qx?
Isn't it just ymx plus c?
Is it?
Can you ymx plus c equation qs? I mean, equation qs is a line. Qs is a line. So find the equation of the line. Oh, ymx plus c.
Oh,
Finding a line. They don't say go and find a line. No, but you must understand it as find a line. Simple. Find a line or find a point. Remember, our business is just that 2-1. Find a line, find a point. Find a point, find a point. Find 2 points, whatever. Okay? Then, Elliot, do you think you can find a line?
yes.
All right. Give it a try. Oh, Chiwan, you sent me something. Wonderful. Oh, nice, nice. Do you find this to be difficult or easy, Andrew?
I think relatively easy, but I will need to go through a few more times before I'll like truly long-term memorize it. Like for now, I can memorize it, but I'll probably forget it 1 or 2 days after.
Totally acceptable. You hear me? Yeah? Totally acceptable. My purpose is not to ask you to permanently have it. I'm asking you to familiarize yourself with it. Okay. For example, that means today is the last day we meet this week, right? Okay, we'll meet again next week, right? You have memorized the 3 big things: the gas, the negative ion, and this is the positive ion identification. 3 things, correct? I forbid you to revise. Okay, this is not what I normally ask my student, but this is very far from exam. So I forbid you to revise until we meet again next Wednesday. Okay. Next Wednesday, when we meet, immediately write down the 3 things. Of course, you'll be patchy and of course you'll be rusty, but I think you won't forget everything. I don't think so. Right?
Yes.
Immediately write down and then immediately correct yourself. That should take at most 10 minutes. Remember, I'm not asking you to revise before tuition. I'm not asking you at tuition start, you look at your paper or the Jamboard. No. I'm asking you immediately write down something and then you look at the Jamboard and then correct yourself. That's it. Understand? Can you?
Yes.
This is not the normal way that you will train your memorization, but that is how I will do it with you this few times. Okay? Now, considering your tiredness, do you think it is better for you to do, there are 2 more memorizations. I just want you to familiarize with that, but you're tired. Better do memorization more or better do more question more?
I think memorization can.
Okay, then let's go through still the same Jamboard, okay? Still the same Jamboard. I will ask you to go to page 4. Yeah, okay. Looks complicated. I'm trying to simplify it for you. Elliot, are you okay so far?
Yeah, I think so.
Okay. Have you found the QS?
Just equation, right?
Yeah, just the equation. Just ymx plus c.
Yeah, I think.
Okay. Then can you find Q? Not S, yeah? Just Q. Can you find Q or not?
Yeah.
Oh, you can, then you do. If you're stuck, tell me, yeah? Okay. Now, Andrew, I'm simplifying the table for you. This table is very simple one. This table is something like this. When a cation, positive ion, meets an anion, negative ion. Okay, so many cation, so many anion. Don't be afraid. First of all, the table purpose is this. If sodium positive meets fluoride negative, will they be soluble? Soluble means this. Soluble means will they actually simply be separate in water? Do you understand this? soluble means they are actually separate in water. You don't understand?
Mhm.
Insoluble, so Mg2 meets F minus, right? Is insoluble. This is not a formula. This is like practical experiment one. Why are they insoluble? Because the experiment says so, right? Okay. Insoluble means they decide to hold each other very tightly, therefore precipitate. Sodium and fluoride minus, they decide to be separate, therefore they do not precipitate, therefore it is called soluble. One more time, huh? This table simply tells you who decide to stay apart, who decide to hold hand very tightly. Insoluble, soluble. Am I making any sense?
So soluble means it will like
Stay apart.
dissolve in the water.
Correct. Dissolve means stay apart. I'm pressing upon you this understanding. Stay apart. They are not together anymore. They are Na plus flying around and F minus flying around free.
That's soluble.
That's soluble.
Okay.
That's why they dissolve, because they decide to stay apart. What does insoluble mean? They decide not to stay apart. They decide to stay together. That's why they don't dissolve.
They're like separate things in water. That's why they precipitate. Is it?
Precipitate means they're not separating, Precipitate means they're holding each other. They become a solid. That's why there is a precipitate. Am I making any sense? If not, let me try again. What do you think, Andrew?
Okay, I guess. I think I get it.
Okay, so insoluble, don't think about insoluble. Think about, oh, they're holding hand together, a precipitate. Soluble means, oh, they are separating in the water. Also, soluble. Now, this table exists to tell you who is soluble and who is insoluble. The strange thing is, O-level wants you to memorize this. Now, that's the bad news lah. So many lah. Here's the good news. They take out most of the super complicated one. Like this F minus is not fun to memorize. One guy soluble, one guy slightly soluble. What the heck is that, right? This is soluble, so when this suddenly insoluble, whatever. No need to do F minus. No need to do this. No need to do that. No need to do this. No need to do that. Okay, the one with red, no need to do. So far so good. This Mg2 plus Fe blah, 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 also no need to do. So the rest will be what your syllabus will ask you to memorize. So far, so good?
Yes.
Let me make it even easier for you. Look at NH4 plus, lithium plus, sodium plus, and K plus. Isn't this simply all soluble? The one that you need to memorize. This four never decide to hold hand in water. They always decide to separate. Always. Easy to memorize, right? Look at nitrate. Same thing lah. Nitrate decides to always separate, no matter who is from. Okay, simple, yeah? So what remains is the rest. Look at chloride. Okay, chloride. You have exceptions. You memorize the exceptions. You understand me?
Okay.
Bromide. Oh, exception. Let me give you another good news. The exception are usually repeat offenders one. Do you understand me? They are usually repeat. You understand what I'm saying?
Yeah, I can understand.
You memorize the exception. There will be one or two difficult ones, but most of the time you can summarize it by it's usually soluble, but exception,
Okay.
Carbonate is the reverse, okay? Carbonate is actually usually insoluble. You see that? Usually is insoluble, except the 4. But the 4, you know already what? The 4 is always soluble one. So carbonate is always insoluble, but only the 4 is not very difficult one. You understand me? Do you think you can memorize this?
Yeah.
Give it time. Elliot, how are you? What's your Q?
I don't know. I don't know.
Wow. Okay, tell me your QS first.
My QS was why improve 5/3x plus 2.
Okay, so you're saying that the 2 is this guy lah, right? Use your visual sense. Does this roughly look like 2?
Yes.
You should be rather happy. It's not guaranteed to be correct. Why? Because look, the diagram is not drawn to scale. But I mean, this does look like about 2, right? Correct or not? About there lah. I can be a little bit encouraged by it. It doesn't mean that I'm wrong. Understand?
Yes.
But okay, you are happy. That's another bonus in using the drawing as, as a way to analyze. That is what I'm teaching you today, right? Now, Q. Q first, not S. Do you know why Q first, not S?
No.
Because Q is half point, S is no point.
Okay.
I should start from the one that at least I know half already. Now, let me tell you something. Half point had a chance to shine now. I know this line. I know half a point. Ayo, come on, Elliot. So easy. Elliot, so easy. Shoot. See what I'm doing?
That's how I put.
Okay. You put that. You should get some sort of X.
Then I don't know how to continue.
Huh? Wait. You're A math student. Come on. Right. So 0, right? Because the Y is 0, correct? The Y coordinate is 0, right? So 5/3x plus 2. You have to find X. Seriously, you don't know how to do this? Really? Yeah. Really, man?
Nah, and I know. Okay.
Are you sure you don't know how to do this? Hey, come on. Think simple stuff. Don't think complicated stuff, right? Think simple stuff. Andrew, are you okay so far?
Yes, I'm okay.
Sure thing. Elliot, now?
Yeah.
Okay. What's the X? It's an ugly number. What is it?
6/5.
A, come on. It's not 6/5. Come on. You're missing something. Come on.
-6/5.
Now you sound very unsure. Look at the drawing. Which one? Look at the drawing. 6/5 or -6/5?
-6/5.
And according to algebra, because you have to do algebra, isn't it also -6/5? Correct or not?
Yeah.
So the picture is encouraging you. I hope that's what's happening. The diagram is not drawn to scale. Let me tell you the manners of a question maker. He cannot bluff you in. If he draw the Q at the negative side, that means it is on the negative side. He cannot bluff you. Q is actually on the positive side. Then he go and draw on the negative side. That is not allowed. That's no manner. That's very misleading. Meaning you can somewhat trust the drawing. Do you understand what I'm saying?
Yes.
If the drawing thing A should be negative, your answer is positive, you better think again. The drawing must be correct one. Something like that. You get me?
Yeah.
The circle question sometimes no drawing. Do you know why or not?
No.
Because they don't want to spoil it. If they draw, it becomes easier. I know most people don't use the drawing, which is like a very bad thing. It is a very bad thing. When they give you drawing, you don't use. Stop so many problems. Okay, I'm going very slow right now. This is already 1.5 hours. Do you want to continue or let's just see each other later, Elliot?
Each other.
Then let's talk about S later. Okay, Elliot?
Yeah.
Good job. I'll see you later. Bye.
What time is the next one?
8:30.
Oh,
Okay. Yeah, go and have your dinner and everything.
bye-bye.
Bye. Andrew, I go take something first, yeah?
Okay.
Oh, forgot I'm muted. Andrew, how are you doing?
I'm doing fine, but it's like a lot, so it'll take some time.
All right. Where are you facing trouble? Tell me.
Not really facing trouble, it's just a lot.
Hmm. Yeah, since I do want you to, okay, tell you what. Okay. I just want you to be familiar, right? Okay. So close your Jamboard, close your paper, okay? Just on top of your memory, okay? Okay, yeah.
Okay.
So the ones who always separate, who are they?
Always separate.
Mhm.
So it's insoluble.
Yes, always.
All the nitrates, I guess.
I'm sorry, you're saying? Sorry.
All the nitrates.
All the nitrate, yes. Anybody with nitrate won't hold their hand, so to speak, right? Okay. And okay, that's the negative one. The positive one have 4. Who are they?
I haven't memorized that yet. I've only memorized the negative.
I'll tell you. Ammonium, NH4 plus. Lithium,
Ammonium.
Li plus. Sodium, Na plus. Potassium, K plus.
Okay.
What are the 4?
Potassium, ammonium, lithium,
Yes. The first guy is ammonium.
ammonium.
Right. All of them are pluses lah. NH4 plus, Li plus, Na plus, K plus. Okay.
Okay.
Now the chloride, Cl minus. Cl minus are usually holding hand or not holding hand.
Chlorides. They're usually holding.
No, usually they don't. Usually they're separate.
Oh, sorry. Soluble.
Yeah,
I keep mixing up soluble.
You're usually separate. Okay, so but
separate.
they will hold hand with 2 guys. Who are they?
Silver and lead.
Good. Now, since you're a pure chemistry student, I want you to get used to the chemical formula. Ag.
PB and AG.
Correct. Not just the PB and AG, but the how many plus. So it is a bit of memorization. Ag plus PB 2 plus. Memorize. Okay.
AG plus PB 2 plus. Okay.
Okay. Yeah. Not so bad. Huh? They are repeat offenders. Ag plus and PB 2 plus are repeat offenders. For example, bromide, Br minus lah. Usually holding hand or separate.
Usually separate.
Yeah.
Except for silver, Ag plus.
Yeah,
sorry.
very good. And then, yeah, sorry, the chemical formula.
Then
Yeah.
for PB 2 plus, it is slightly soluble.
Very good. Wonderful. For your syllabus, for some reason, they think of it as insoluble. So slightly soluble is almost similar to insoluble, at least for PB.
Okay, so I just, okay.
Iodide also usually.
Iodide is usually separate.
Good. And the repeat offender is the one that is
Same is PB 2 plus and AG plus, which is both soluble.
No, it doesn't mean that insoluble is bad or soluble is good. It's not what I mean. It just means that later you'll see, depending on the situation, you may like one or the other, right? But
okay.
That's not what I mean. Yeah? I don't mean that soluble is always good. Now, so let's move on. Okay, so far you're getting a lot, right? Now let's talk about, for example, sulfate. Okay? Now, according to you, sulfate is usually holding hand or usually separate, or what do you think?
Sulfate. Forgot already.
Yeah, but let me tell you the good news. The repeat offender is back.
Okay.
What the repeat offender?
The repeat offenders nitrate.
No. You're talking about
sulfate.
Negative. Your usually is soluble. Maybe let's not say that, but the one holding hand with him is a positive ion, which tends to hold hand with everybody. So With sulfate, it's that guy again, no? Ag plus again and Pb2 plus again.
Yeah, and there's another two, but I forgot.
Which belongs to group 2, and so happens that they're going to be in pattern. Barium, Ba2 plus, and calcium. Now, let me show you why barium sulfate is important. Look at this guy.
Go back. Okay. Yeah.
Do you see?
Gives off what PPT.
Because sulfate needs barium 2 plus. Just like what you memorize just now. Correct?
Yep.
Okay. This is talking about the exact same thing. How do you identify sulfate? By letting him hold hand with barium 2 plus. One more time, the sulfate is actually usually simply soluble, just very happy, usually. The moment you introduce barium 2 plus, he will decide to hold hand. Identity.
Okay.
Make sense?
Barium.
So the one that you forget, barium 2 plus, turns out to be an important guy in the this anion identification. Meaning to say, I mean, you don't have to double memorize. So to speak. Okay. Look at what happened with chloride, bromide, and iodide. Look at that. They are aqueous usually, so they are usually separate. And then they will give off CPT by holding hand with who? Look at that.
Oh, we are repeat offenders.
Repeat offenders. You understand me?
Understood.
In general, when people realize this, it's actually a good thing, not a bad thing. In general, so that's why I'm telling you, because some people just don't realize it, even though they memorize it very well. Okay, it's a minor thing, lah. It's not a major thing, right? But it's just a good thing. Okay. Yeah. So back to the so there was sulfate, look. There was sulfate. Sulfate will usually be separate, but he will hold hand with Ag plus, Pb2 plus, and barium 2 plus and calcium 2 plus. Okay. What is left? There's only two, hydroxide and carbonate. Okay. Now, let me tell you about hydroxide and carbonate. Hydroxide and carbonate is also kind of easy to memorize. They are usually holding hand, no matter who.
Okay.
Okay. Just like that, look. Usually, look. Just like that. I know they're sometimes slightly soluble and whatever. O level kind of just pretend that they don't exist and just pretend they're just insoluble.
Okay.
Okay, that's it, look. Okay. Okay. So I'm helping you through the memorization for the sake of making you feel that you're familiar with them and making you feel that, yeah, maybe you can use them. Let's see whether we can use them. That'll be next week, right? I don't think we have time. Okay. Okay. Now, can you memorize more? There are still two more. There are still two more. There are still two more.
Last two.
Yeah. Last two big. Hey, wait. Last one, last two. Sorry.
Which one? The anions.
Only last one. Only one more. Sorry. Only one more.
As in the sulfate?
No. Let's call this big table done for now. Let's call this.
Okay.
You're familiar enough, and next week, next Wednesday, don't revise before that. Next week, just try to whack them. Okay, let's try.
Okay.
Okay. Now, can you do one more memorization? One more big thing.
Memorization. Okay.
So let me show you what you are to memorize. Okay. So no, never mind. I'll just go in front and create a new page. Sorry. Yeah. Okay, so on page 5, then please go to page 5. Okay. So this is called the acid and base list. Acid list and base list. Let me confirm, have I gone through you the acid and base list? If you have not,
Acid and base list.
that means you have to know that they are acid and base immediately when you see them.
Oh, I think I know most of them. Acids I know, but bases
Right.
I may be less familiar.
Acid is HCl, then
H2SO4.
good. Okay.
NHO3.
No, HNO3.
HNO3. Okay.
Then
And I forgot the rest.
let me give you. Let me give you. It's a bit rare, but do know that it's an acid.
Phosphoric.
Yeah, phosphoric. Yes, right.
I forgot the formula.
Which is, look at the formula for a while. This is Cl minus, this is Br minus, this is I minus, correct? H plus, Cl minus, H plus, Br minus, H plus. It's the same thing all over again, correct?
Yeah.
With the previous table, even though they don't seem to be related. In truth, they are related, but when you memorize, you don't seem that there's a relation. I'm pointing out the relation. This is how your SO2 minus just now, correct? This is nitrate one. NO3 minus. NO3 minus exists in, turns out, this list, the solubility list, whether you hold hand or not, and the negative ion identification. They exist in 3 things, right? So does this thing, so does this thing, right? So it is quite popular, those things, and turns out that they form acids. The phosphate, they kind of spare you from memorizing the solubility one, but here you are, it's an acid. 2 more. CH3COH is your weak acid, your whatever, ethanoic acid.
Ethanoic.
Yeah, but
Oh yeah, that's very long.
This guy's acid. Right? One last one. H2CO3 is a rather special acid because this is the shy guy. There's one shy guy in the acid. Let me give you the base shy guy. This is the shy guy in the base. You gotta remember that this is the shy guy. What do I mean by shy? He refused to be acid. This shy base refused to be the base. How does he refuse? By
So he's both acidic base and
let me put it this way. Okay. If H2CO3 ever exists, it exists, he will immediately, not very fast, but immediately start to break himself into H2O and CO2.
Oh, okay.
Not instantly, it's not an explosion, but you will immediately see some bubble. This is him refusing to stay as acid.
Got it.
But
so refuse to stay in one state.
Refuse to become an acid. Just refuse. I don't want. I want to become water and carbon dioxide gas. Okay. All your syllabus O level, only this guy is a shy acid. Only this guy. For the base,
what do I call it? Acid.
Carbonic acid.
Carbonic acid. Okay.
The base, that ammonium the ammonium hydroxide, that's the same thing. No, he refused to stay. He will immediately, though slowly, break down to ammonia. Okay. The acid list is not complete without the last one, which most people don't realize. Non-metal, okay? Non-metal oxides. Non-metal oxides. In the base side, it is the metal oxide.
But for Non-metal oxides, they can also be neutral oxides though.
Very good. You already learned it. Tell me the exceptions. So you need to memorize the exception.
Forgot.
Okay, let me tell you immediately. Except three things. Except three things. CO, NO,
Carbon
H2.
monoxide. All
No.
the monoxides. Yeah.
Monoxide. Carbon dioxide is acidic.
Yes.
Carbon monoxide is exception. NO is an exception. And H2O is water. Well, that one I know, right?
Yeah.
The metal oxide also have exceptions.
Okay.
ZNO, PBO. Hey, PB again. My goodness, PB. Aluminum oxide. I think aluminum somehow exists in the thing also. It's just that it's not very fun, right? This tree, you call it not base. You will call it amphoteric. Amphoteric is a fancy name for if I meet acid, I am a base. If I meet base, so you have heard about
acid. Yeah, I heard of it.
The whole purpose of this list is going to complete very soon. The whole purpose of this list is acid and base, when they meet, will always react. Whether slow or fast, we don't know, but they will always react. That's why you memorize this list.
Oh, the acids and bases was tested in my term 2.
Oh, you already went through it. You just haven't went through what they call solubility and salt making lah.
Yeah, no, those two haven't. Salt making and solubility table haven't done.
Correct. You will need this in your salt making one. This is because turns out that salt making is just acid and base plus turns out.
Oh, okay.
So don't worry. Everything we're memorizing will be just directly useful in terms, right? So this is a revision. Good. Now let me complete the acid and base. Acid and base list is so simple. Base is simply metal hydroxide low. Every metal is a base. Every metal hydroxide is a base. Every metal oxide is a base, except for these three, which is also a base. It's just that they become acid also can. To be fair, base list is so much easier, to be fair.
Okay.
Metal hydroxide, metal oxide, except these three things, which is also a base, by the way. And then this shy guy, which simply refused to be a base. Okay.
It's still considered a base.
Oh, still. I mean, because it doesn't break down immediately and totally, it breaks down rather slowly. So given the time, he can reach as a base load, given the time, but he will like slowly disappear, something like that.
Okay, got it.
So slowly doesn't mean 3 days. Slowly means like, I don't know, 1 hour, something like that. Okay. So give yourself some time, memorize this, and then we can probably try some questions. Okay. Or rather, can I just ask you to write on paper immediately? Can I ask that?
For the acid base.
Acid and base.
Okay, give me a few seconds first. Just digest it.
Ananya, can you hear me?
Yeah, hello.
Yeah, sorry, how long were you there?
Like 2 minutes. It's okay. I just came.
Just call me, just call me. Sometimes I don't see, call me. Right, okay, good. Okay, so while Andrew doing that stuff, right? Okay, Ananya. So where were we? We were doing the astronomy thingy, right? Astronomy, right? Are we continuing from there?
Sorry, what?
Continuing from the astronomy?
Yeah, astrophysics.
Physics, sorry, astrophysics. Let's do that. Okay, let's do that. we slow.
I think we might have to start a new Jamboard since this one is at 20.
Oh, please do. Please share it with me also.
Okay.
Both of you and Daniel are preparing for an exam like after holiday, right?
Yeah.
Um, uh, actually, do you wish to talk about other topic besides astronomy? Astronomy has a positive and negative side to things. We are going to talk about it this time before exam. That might be enough. That might not be. I don't know. That might be. That might not be lah. Right? Because we haven't practiced much. You can decide for exam purposes to strengthen other topic first. Then, after exam, we're gonna let this topic go, and then after exam, we can strengthen it again. That depends on what you think about the other topics, right?
Mm.
Are you sure today you want to talk about astrophysics?
Actually, it's one of the topics tested. Like, I only have 4 topics tested for the upcoming exam.
Oh, I keep forgetting that.
Yeah, so it's like,
Okay, let's do that. Okay, sorry. Okay. So waiting for your new Jamboard.
I shared it with you. Yeah.
So Andrew, as per usual, when you're done, you send it to me. Yeah.
Okay.
Tell me when you send it so that I know. Yeah. Okay. Right. Oh, no, wait, sorry. So back then we were discussing a question. We shouldn't go to a separate one. We have to talk about that, but if possible, another question. Because if I'm not mistaken, we finished the slide, though it's a little bit unsatisfactory, right? At least I feel very unsatisfied.
We didn't really finish the last slide. It was like a mind map kind of thing.
Oh yeah, that luminosity thing. Yeah.
Yeah.
I have to explain that. Sorry, I have to explain that. Let me explain.
Okay. Do you want me to paste in the new Jamboard?
Fine. Let's paste that one slide or two. Oh, sorry, whichever slide you want. But there's one which I want, the mind map and the calculation.
Yeah, the mind map one. Yeah, okay, I'll paste it.
Let me explain that. Please do.
Okay.
If you have trouble, please tell me.
Sorry, but for the bases, do I just list all the bases too, or just what is written in the Jamboard?
Basically, you just have to remember metal hydroxide, metal oxide, exception, and the shy guy.
Oh, the exceptions. Okay.
So I mean that's how easy the base is. Right. So I'm gonna try explain luminosity. Right. I did tell you to think about your table M, right? When you go further, you can see it directly.
Yeah.
Go closer, you cannot see it directly. The reason is very simple. Let's imagine now your lamp is the sun. Now we cannot see sun directly because very simple. So remember, I told you to imagine that the sun outputs like, for example, 1,000 photon every second. Let's just pretend that 1,000 photon, very deeply packed, right? Because the circle is very small. This circle doesn't stay densely packed as the photon travel, because the photon travel like that, suddenly in a bigger circle, there is still 1,000 photon, but less than. Make sense?
Yeah.
By the time it reaches Earth, here's Earth, a small guy, you are probably hit by, well, I don't know. It's not very many photon because the circle is now very big. The circle is now very big. Therefore, the photon has been spread. If this makes some sense.
Yeah. I think so.
Now I'm gonna make a simple calculation to show you how we can handle this thing. Now, brightness. Oh, that's not very nice. Okay. Brightness is sorry. In your other chapter, do you have the term called intensity?
Yeah, we do. I don't remember.
Or is that which chapter?
Is that definition?
No. As in a chapter that actively uses the concept of intensity. Do you have that chapter?
Yeah, we do.
Which chapter would that be?
I don't remember.
Okay,
I think it's like it's like I equals to 4
yeah,
something.
something like that. So it's not 4, yeah. So intensity, right? So now, whenever I mention the word intensity here, it will be brightness. The meaning, the common term for us normal people is brightness, and brightness simply refer to how you feel about a light. Low, is the light too bright, or is the light not very bright? So far so good. Can you? Now, I already asked you to experience that your table lamp is brighter or too bright when you're too close. And your table lamp is not as bright when you are further. Okay. Does this make sense?
Yeah.
So that is the meaning of apparent brightness. Apparently to you, your table lamp is less bright when you are further, even though the lamp has been outputting the same brightness all along. Nothing changes. It's the distance that change. Your eye experience less or more brightness. That is what it means for apparent brightness. So far so good, yeah?
Okay.
So that apparent brightness is going to be your apparent intensity. So your intensity is very simple. Intensity is, let me give it something simple. It's going to be your total photon. Let's just put it that way first. Your total photon, okay, over what you call the surface area. The surface area of this thing. Now here comes more complication. This is not a circle, but this is a imaginary sphere. Can you accept that this is an imaginary sphere? The photon is spread not in a circle, but in a sphere all over.
Yeah.
Okay. Surface area of a sphere is, if you don't remember, tell me.
4 pi r cubed.
Yeah, square. Surface area square, 4 pi.
Oh.
Right. So the intensity, remember intensity means brightness. The brightness we experience, the apparent brightness, right? Apparent brightness, the brightness that you experience depends on, obviously, the total number of photon that the sun emit, in this case, or your lamp emit, spread over spread over a sphere.
Yeah.
The sphere can be as big or as small as you want, depending on how far you are. That's the effect of this thing. Technically, you must include time. I'm going to pretend for a while and put that time and don't explain anything. The time is there. Just acknowledge it there without much explanation. I want you to focus on its total photon spread over a sphere. Okay? Yeah. So far, so good. Yeah. Okay. So, Andrew, have you sent it to me? Right. Just a minute. Yeah.
Yes.
Yeah, it's true that you missed the shy ones. You forgot the exceptions for the non-metal oxide, please. The exceptions.
Exceptions. Okay.
But the neutral one, the one that you know exists. Right? Okay. So, now, can you now appreciate one thing about astronomy? Now I'm moving to astronomy. We are measuring stars. Don't know why. We're very interested in measuring the distance between a star and us. Okay. It's a very complicated matter because it is very far. Far means like really far. I mean, astronomy do very silly stuff sometimes. We are measuring distances where we will never go there one, you know. I mean,
Yeah.
I go measure distance to Japan. I might go to Japan. I measure distance to North Pole. If you want, you go there, lo. You will never go even to the nearest star. And then they go and measure all this star distance, right? I enjoy the result of their work, but I don't fully understand why they want to measure stars distance. That's my personal feeling. I do, however, enjoy the beauty of the sky. Something difficult to do in Singapore, lah. We have to do elsewhere, right? But there you go, lah. Astronomers do that, and suddenly you learning physics SL have to learn all this. Right? So let's get on their perspective for a while. Okay, Andrew, are you okay so far?
I'm fine, but just not very sure about all the neutral oxides. I only remembered the carbon
CONO,
monoxide and
H2O.
and OH2
Yeah, H2O, H2O. Water. H2O.
and water.
Water, ONO. Okay, okay. Good job. You're familiar with everything for now. Okay, in the remaining 10 minutes, would you just look at page 8 and this is a revision for the whole chapter. Okay, just slowly revise it because I also want you to be familiar.
Okay, thank you.
Okay, slowly, 10 minutes, do stuff, and then that's it for holiday, right? I want you to enjoy holiday lah while it lasts. Okay, now back to you, Ananya. The thing that we can measure from Earth is not the distance. The distance have to be measured indirectly. That means use formula. Making any sense? So what is the thing that we can measure? Look? We must still be able to measure something from Earth. If not, cannot use fully Formula 1. That doesn't make sense. Something must be directly measured. Then something is indirectly. For example, the distance will be indirect. What can we measure? The thing called apparent brightness law, which is simply how many photons do we receive every second from whatever star that you're looking at. That's quite easy to measure. It's really just aiming a sensor to the whatever sun there is, whatever star there is. That's all. So we can measure it. And usually in the question, they will give you that because that is the representation of what the astronomer is doing. Therefore, they will ask you distance. Why? Because that's usually what the astronomer looks for. It's kind of predictable that way. In a Cepheid star question, the super weird question that I was complaining, hey, you're supposed to discuss Cepheid star in your slide, not in the question. That's so weird, right? The Cepheid star will give you measurement of brightness or luminosity. Because why? Because that's what we can measure from Earth. I mean, there isn't much other thing, to be fair. And yeah?
Yeah.
So that's one thing you can measure. Okay. Another thing that you can measure is the spectrum of the star. I keep telling you, right? I can measure the shape of the. Sorry, when I say spectrum, do you understand what I'm saying? Spectrum.
No, not really.
Apologies, not the not the most common thing lah. So I have to quote your chapter 8, I believe, the black body, just for a while. Okay, don't be scared. They will give you this thing lah. The spectrum simply goes like this. Oh, so I measure. Oh, this frequency of light how bright, this frequency of light, how bright, meaning to say the light we receive from sun, for example, is not one color one. It is many color, but not of the same brightness. They just simply go and measure, or color blue is less bright than color yellow. Color yellow is very bright, that's why our sun looks yellow, but actually our sun contains blue, contains green, contains red, just not as bright as yellow. That's a spectrum. So far so good?
Yeah.
A spectrum is therefore not what our eyes can see. Our eyes usually only see the brightest color, but a spectrometer can measure many colors with its brightness. Make sense? Yeah. So far so good?
Yeah.
So two things we can measure: the brightness itself and the different colors of the star. We can do that even though it's very far. Andrew, are you okay so far? Are you lost?
Sorry, I'm just getting into the gem board because the computer's kind of slow.
So, Ananya, two things we can measure. We can then infer oh goodness me. He goes one step further. He wants to go and measure the radius of the star. Never mind. At this point, I don't want to explain. I want to explain inside the question. Okay. Could you please give me a question? Just not the separate one. So I can show you in practice. Can you do that?
What kind of question? About apparent brightness?
I cannot hear you. Sorry, I cannot hear you.
A question about apparent brightness?
Just give me a question about a star.
Oh, okay. Let me find. Can I give you a question about eclipsing binary stars?
Just show me first. It's just that I think binary star is not this topic. Just show me. Just show me. Sorry. Binary star is a gravitational field one, but yeah, just show me.
I'll screenshot.
Andrew, are you okay?
Yes, I'm starting already.
The page 8 question are the practices from the mole chapter. The mole chapter discussion is the pages like the pages before.
Okay.
Just getting familiar with that. Okay, I think I haven't received anything.
I put it in the second page of the chamber.
Surface temperature. I like apparent brightness. I like. Okay, so this one is nice. This one is very nice. Good. Yeah, obviously they just go full astronomy on you, isn't it? Okay. Now, so this is my chance to explain to you the terms. So remember, I told you the apparent brightness is what we experience or what the star actually is.
Yeah.
Which one? No, sorry, that's a question.
What we experience.
Okay. Now, luminosity, in part 1, right? A1. Luminosity is what the star actually is.
Okay.
Remember your table lamp. Your table lamp luminosity stays fixed, but the apparent brightness we experience depends on our distance. Am I making any sense?
Yeah.
Now, star A apparent brightness is bigger or smaller than B?
Star A.
It is a very small number there, but you have to know which one's bigger.
Star A is bigger.
Yeah.
No, Star B is. Oh,
Brighter or dimmer? Which one?
Star A is brighter.
Okay, brighter in our eyes. Okay, remember, that's our experience. That's why I say apparent bright. How come they don't just give you luminosity? Because you cannot do that. You cannot go to the star and measure one. Cannot what? We can only measure what we experience. So currently B is dimmer than A, right? Dimmer than A. Now, part A question, you have to understand first. Part A question is saying that, even though B looks dimmer than A to us in Earth, is it possible, or how is it possible to deduce that actually, he go and ask, why don't he go and ask the other way? Right, so he basically wants you to confirm, look, B is dimmer than A is brighter than B to us. So could you please confirm that A is actually brighter than B? Okay, does the question make sense?
Yeah.
If the question makes sense to you, then the answer is very simple. Just, for example, if I know the distance, I can tell lo. I can work backward lo.
Okay.
I have a distance, I can work backward from apparent to the actual one, something like that. So only if I have a distance. If I don't have a distance, I cannot do it. Let's just put it that way for now. That's the explaining part. You're not supposed to do it anyway, right? Am I making any sense so far?
Yeah.
Andrew, are you okay so far?
I'm not very sure anymore.
Yeah, Andrew, yeah. Okay. Just a minute, yeah. Okay, I'm gonna just explain you something else before letting you go, yeah. Just a minute. For you, Ananya, I want you to use. Show you something, Ananya, and I hope you can do it. I'm giving you something, yeah. So surface temperature only appear in this formula, whatever that formula is, correct? By the way, this is formula of luminosity lah, and the L always means luminosity, like the real brightness, you know, the real brightness. If you want to measure the surface temperature of B over the sample A, then I mean you can do it by TB over TA lah, right? Correct? And you can use this formula. Now I'm engaging your math. At this point, you don't know what the formula means, but you can use it like math lah. Just use it. Please try. Okay. Okay, Andrew. Look at question 12. Are you with me? Question 12 on page 8.
Yes, question 12.
Let me explain to you what this question is. This question is saying, I give you the reaction, correct? The reaction is balanced. How do we know? Because he don't say it's not balanced. How will he say it's not balanced? Very simple. He will write something like this. Give you an empty space, empty space, empty space. Like literally make a line, which is an empty space. Do you see any empty space?
Sorry, for what?
Okay, one more time. Do you see any empty space in front of the elements?
Yeah, all of them.
However, the empty space is just a space. It doesn't have a very direct empty line like that. There's no line. There is no line, then he's saying to you, it's balanced already.
Yes, balanced. I know that, but I'm not sure how to get the answer.
Oh, very good. Very simple. Look, stick to the mole. They give you gram, you must go to the mole. How do you change from gram to mole? Remember?
I forgot.
Look at the page. actually use MR. Remember, it's not obvious. It's not natural. You have to memorize. So
Yeah.
find what is MR.
Page, but I can't really read it. The page just of the formulas.
Oh, never mind. The MR of carbon is 12.
Of carbon is
Yeah, MR of carbon is 12. How do I know? Periodic table.
periodic table.
I have to find it from periodic table, right? So you have to read the periodic table. So now because I memorize, I know already, it's 1.5 mole. Understand? 18 over 12, the MR. So far, so good, Ken? Okay, 1.5 mole is the mole of carbon. He wants carbon dioxide. What is the mole of carbon dioxide?
The mole of carbon dioxide.
1.
Hmm.
That's the reason why you balance so that you know this number.
Oh,
This is 1, 2, 1
yeah,
mole.
it is the same.
Yeah, 1.5 mole.
1.5.
So this is also carbon dioxide. Finally, I have the mole of carbon dioxide. I want to change it to volume because that's just how gas is measured. Correct? According to
Work backwards.
remember, 1 mole, 24 dm cubed. Correct?
Yeah.
So
24 dm.
1.5 times 24 is going to be
1.5 times 24 is going to be, I think, 36.
yeah, 36. And the answer would be 36. Like that low.
Okay, got it.
That's a revision. That's it. Enough for today. You memorize quite a lot. You are a little bit more. Next week, we'll jump right to it.
Okay.
Good job today, Andrew. I will see you next week.
Thank you. Bye-bye.
Okay, Ananya. Ananya, can you do yes, correct.
Wait, so do I use the other formula also? The L equals to 4 pi d square?
I kind
Or
of
is it just
think that you're supposed to use this, right? Okay. No, because this and this are just the same thing one. This B is this guy one. You don't ignore this guy. Okay.
oh
Ignore that guy. Ignore that guy. You only have
okay.
this is the better formula because it's a more complete one, right? More
Yeah.
complete. Yeah. So ignore that guy one.
Okay.
Now, again, I'm asking you to don't care that you don't understand this formula. What the heck? I'm asking you to just use it like math. Just use it lah. Okay. You want TB over TA. Apply. Can you apply? Okay.
So,
Watch me apply. Yeah? Watch me apply.
okay.
LB lah must be the luminosity of B, man. Correct. Must be lah. Okay. And luminosity means what? Tell me.
The brightness of the actual brightness of the star.
Actual brightness. That's wonderful. All right. Actual brightness. Now, the R. What is the R? What does R mean here?
Radius
of the star, right? The radius of the
okay.
star. Radius of the star, right? Which, just to be clear, this is B. This is what you will call the surface area of B, correct? You will call it that.
Oh yeah, okay.
You do realize, you have to realize, oh, that's a sphere. Okay. Oh, that's the surface area of the star, right? So that you're not confused, I'm not talking about the imaginary sphere. Just now, I was talking about imaginary sphere, you know, how the photons spread from the star. This is not it.
Yeah.
Am I confusing you? Am I confusing you? Let's go back to
what do
page.
you mean this is not it?
Okay. Go back to page 1. Okay, page 1.
Okay.
Here's the star. Okay, this can be a sun. This can be any other star. The sun or a star is usually a sphere, a real gaseous sphere, right? A real gaseous sphere.
Yeah.
Remember, our Earth is a solid sphere. A sun is a gaseous sphere. So a sphere surface area, which is this one, is real. It must be 4 pi r squared. We know that. So far, so good. We know. I am also talking about an imaginary sphere, right? This is an imaginary sphere because, first of all, there is nothing solid or gaseous about it. It's just empty space.
Yeah.
Why am I talking about an imaginary sphere? Isn't a solid sphere or a gaseous sphere hard enough? It's because in some other question, the photon starting from the sun, right, will have spread here. And so we have to care about this imaginary surface area, the imaginary sphere. Okay. We are not concerned with the imaginary sphere in our current question in page 2. This formula represents the actual star surface area. Okay.
Oh, okay.
I have to clarify this because the formula doesn't seem to tell you this is this and that is that. You will see later that there will be the other one. Okay, yeah? Yeah.
Okay.
So now this is surface area of B, and then there's also a sigma here. Since I'm lazy, I'm going to put my power 4 here first. I don't think the power 4 will give me much problem later. Okay?
Thank you.
Okay, and now I have the L of A, right? I have the L of A, and then I have 4 pi RA, right? 4 pi RA square, which is this is the surface area of A, right? And then this will be the Stefan Boltzmann constant. Now math. Can I do that?
Yeah.
Okay, math also. They tell me that this. Can I somehow use that here? Cannot. So I'll write it this way lah. SA over SB is I think that means 10,000. Correct?
Yeah.
Okay. Can I actually use it here then?
You can like convert.
Yeah. Can you please do that? At least let me see your
SK.
math. Let me see your math. At least your math is strong, so I want you to use it. Right. Do write something.
So do I rewrite the 4 pi r square as SA and then?
In this case, I believe so. That's easier, right? I believe.
Okay.
So
Okay, I'll just rewrite it.
okay. So am I saying okay? Right. Okay. Yep. Nice. Yeah. Yeah. Sorry. Yeah, that makes sense. And I'm looking for cancellation. No?
Oh, okay. So
Cancel what you can if we can.
how's it open? Okay. So then
Okay. Okay. All right. Okay.
what?
Let me just confirm that you can simply cancel the SAB with the SAB, right? You can. Am I correct? You can do that. So this is the case of physics disturbing your math. So I'm not referring to physics right now. This is really math. If you're not sure, let me explain the math.
Oh, okay, wait, I get it.
Yeah, it's math. It's not physics at all.
Yeah, it's math. Okay.
Okay, so again, this is physics messing with your math, even though your math is strong. Don't let it lah. Don't let it. Okay.
Okay.
Also, I'm doing math. I'm still doing math. Okay, I'm still doing math. Right. Look. I still want to make the 10,000 slightly easier to handle. Look. This LB over LA, and then it's gonna be times 10,000. Do you get the math or not?
I can. Oh yeah. Okay.
Yeah. So this is LA
Yeah, okay.
over 10,000. Then the 1,000 will go up lah, so to speak. That makes sense, right? So this is going to be equivalent to TB power 4, and then again to make our life easier, here. Look at that. TB over TA is going to be now equal to square root 4, right? A square root, sorry, root 4, sorry, root 4, LB over LA, right? Right? Nicely times 10, no? Nicely. I mean, the 10,000 is nothing to help us. Like, it's a bit encouraging, correct?
Okay.
So I don't think this is the final answer. No? I think he still want us to calculate this. I think, yeah. So, which is very weird, you know, which is very, very weird because they don't actually, they haven't given us LB and LA. They only give us apparent brightness.
Yeah.
Apparent brightness. So, hey, what's going on, man? I thought, at least I told you, right? Okay, you are having faith in me. We cannot just anyhow measure the real brightness, the luminosity, right? We can only measure the apparent brightness. How come you're not giving me some other information so that I can go and find it, right? That should be how we think, correct or not? How come it doesn't give us anything, right? I am trying my best to give you a hint, right? Okay, I'm trying my best to give you a hint. They actually did, if you know what a binary star is. Do you know what is a binary star? It's an extremely weird thing.
I think this might be the next chapter because this is the next slides worksheet.
You mean there are other slides other than what you talk about after this one? Really?
Yeah, there are like 2 more sets of astrophysics slides.
Oh, I thought it's done. Oh my god.
No, it's not done.
Oh,
I told you.
No, just send it. First you just send. Oh
I sent you the second one, but I haven't sent the third one. It's on WhatsApp.
I complain about your slide unfair. Okay, I apologize to the slide, to you, and to your teacher, right? Okay.
Okay.
Having said that, Ananya, binary star is just, instead of one sun, we have two suns.
Oh, okay.
This is nothing you have seen. Obviously, nobody has seen this before. I mean, they've seen it in no, actually, they cannot see it directly also. They have to infer it, right? Nobody has seen this directly, but it's really weird. In the center, you have two suns. Sometimes they are the same size. Usually they are not. One bigger, one smaller. Something like that. One bigger, one smaller. Okay. So while you're sending to me, doesn't that tell you indirectly about the distances of the star?
Wait, I sent you the slides already. It's like I sent it to you last week. If you go to our chat, it's probably there.
Stella?
Yeah, the second one.
Now, if you already know their distances, some sort of information, then feel free to tell me, right? If not, we can look at the slide. But I'm giving you hints, right?
Wait, sorry, can you repeat the first thing?
One more time, huh? A binary star simply means, instead of one sun, you have two. And that two stars is in the center together, rotating against each other, right? Just imagine that for a while. Instead of one big sun, I have a big sun and a small sun, really just not very far from it. So if our sun is actually a binary star, we will be seeing two suns instead of one. One may be bigger, one may be smaller. That's a more common thing. Okay?
Okay.
So what about their distance? We are obsessed with distance. What about the distance between the binary star and, for example, Earth? What about their distance? What do you think? Oh, so they tell you, goodness me, I have complained wrong.
I'm not very sure.
Well, doesn't it make they tell you the spectrum, right? Okay, fine. They should, right? They should. Should what do you call it? Most stars will have different distances to Earth. If it is a binary star, two stars next to each other, their distance is about the same to Earth.
Oh, yeah, okay.
That's what they're asking you to infer. They are telling you without telling you. This is not two random stuff which we do not know where they are. They are next to each other.
Also, like the distance is the same,
If
so you can exclude
same,
it from the.
if their distance is the same, then their apparent brightness ratio will be their real brightness ratio because their distance is the same.
Okay.
So that's why in this question, they don't tell you LB, LA. They still expect you to do it because you can replace it with apparent brightness.
Okay.
Right. So they are cheeky that way, no? Yeah, cheeky that way. Now, would you now please do the math, check the answer key, see whether it's correct or not, while I look at the slides and try to skip things, right?
Okay, I do the whole question.
Yes, because you just have to put in stuff already lah. Because now you should understand. Right? If you're stuck, yeah, please.
Okay.
Some slides do tell you what you need to know. There you go. Apologies, I'm going to get something.
Yeah.
How is it,
I start on the next page.
okay, sure. As in, oh yeah, okay. Oh yeah, okay. Right. No, huh?
Can I use the? Wait, so the formula in the new slide, the Stefan Boltzmann one. It's the same as the previous slide. It's just they replace the 4-5 R squared with A.
Okay. So let me explain. For now, I'm training your logic. So sometimes I don't explain how to use the formula. So let me just do that. Let me just do something for you. So let's say I pretend I don't see any of the formula. I'm just giving you very minimum so that you can train your. Sorry, my Jamboard error. Okay, I'm gonna copy it here. So when I was explaining to you the distance, I was trying to explain this problem, there's this problem, right? Okay, so I propose to you that since the distance is the same, I can replace the luminosity with the apparent brightness.
Yeah.
Am I making any sense? So therefore, I'm just going to jump from here. So I'm going to just say, I'm going to root for LB will now be apparent brightness B, right? Apparent brightness B would be 2 times 10 minus 4, 14, right? 2 times minus 14. And then LA, I'm going to replace it with apparent brightness A. So 8 times 10 minus 3, minus 6, right? And then this is times 10. No? Okay. The rest should be math. Would you please take care of it? And then maybe you can check the answer.
Okay.
Okay. You might make a mistake, Ananya. Again, your math. This is minus 14 and minus 13. So I don't think this is about right. I don't think so. I'm actually, let me think for a while. Oh, you are right. No, I'm sorry. You are right. I'm sorry. You look.
Okay.
Can you check the answer key first?
Okay. Finding it. Yeah, it's correct.
Without
They rounded up to 4.
to use the formula, do you understand what's going on?
Without the new one. Yeah.
Right. I'm not saying that you have fully understood it, but at least you understood how to do this question, right?
Yeah.
B.
B is actually incomplete. Like it's split into 2 pages.
Yeah.
Let me screenshot the whole thing.
Sure thing.
Okay, so the next.
Oh, it's on. Oh, sorry, no. Okay. Right, he's going full force now, right? He's going full force, right? Okay, so I have to explain. The heck would I know? Why would they want a SL student to study? I have no idea, right? I really have no idea. Right? So here's Earth, right? Earth. And maybe our sun is here, maybe. Yeah, let's just for drawing purposes. And let's say the binary star is rather far from us. Right? This dot is not the binary star. The binary star will be one small one and one big one. Let's see. Okay. And they rotate each other, they revolve each other, sorry, along a point.
Okay.
Does this make sense?
Yeah.
This star is not revolving around the big star. The big star is not revolving around the small star. They are both revolving at a point. This is simply moment. This is simply moment. You remember your moment chapter?
Yeah.
This is like the pivot of the two things. No? Imagine that there is a stick holding the, of course there isn't, but just imagine that. And this stick will have a balance point. The balance point is rather close to the big star. Still the same. They will rotate against the pivot point. Making any sense?
Yeah.
Okay. Now, why am I telling you all that? Because this diagram looks similar to this diagram. They are not. Please tell me the difference between this diagram and this diagram. Okay. If you
Like
don't know,
from the graph
from the graph.
or different intensity.
Yeah, and why is that so? Never mind. No, I'm just going to tell you. This is so it's so weird that they. Okay, so at a certain point, remember this is like here's Earth, right? That's the line. So I'm drawing this line. Okay, I'm just drawing this line.
Mm.
Certain point, this will be here and this will be here, no? Right? That's the.
Okay, yeah.
At another point, for example, it will be like that and like that, obviously, because they are rotating against each other. What?
Yeah.
So I can see it this way. Look. This is Earth, right? This is Earth, right? Earth. I can see it this way. I see a small and a big one. Okay. To be fair, here, I don't know why I draw it this way. I can also see it like that, and this will be big and this will be small, but the small is behind the big. So I don't know how you can see it in one of them. I'm not sure at all. But this is what he's trying to say. Sometimes I will see it this way, and sometimes I will see it that way. Some other time I'll see two. Obviously, he didn't draw two separate. So I assume that he wants this situation and this situation. Am I making any sense right now?
Yep.
I have just explained to you what this means and this means. So then he go and ask you immediately, state the period of this binary star system. Do you know what that means?
No.
It means how fast do they revolve against each other. That's what period means. Okay. Do you understand?
Yep.
Okay, so based on this and this, what is the period of this? Can you see it? I guess.
Like to complete one full revolution, right?
Yeah, something like that. Something like that.
Only 10 years.
How many?
10 years.
I agree, because from here to here, it takes 5, man. So from here to here again, 5, no? That's 10, no? You are correct, that's it.
Okay.
Okay. So nothing complicated as long you know what's going on. The problem is what is going on, right? What is going on, right? So last part, state what can be deduced from knowing the period, which is 10 years, right? For example, and the separation of stars. What does separation of star mean? Separation means, oh, so I think separation means the distance from each other, right? Okay. Let me think for a while. I'm not very sure. If I cannot find in 1 minute, I'm just going to skip it for now, okay?
Okay.
In the meantime, would you please find another question? Would that be okay? Okay.
Similar question?
If you are, we can just go through the slides. I mean, we only have...
I think, can we do this?
Remember, I owe you the last question, yeah?
Okay.
Okay.
Oh, we can do the separate one next time, right?
Definitely can, right? Because I think the slide will take some time, right?
Yeah.
I am already skipping a lot. Here I'm at slide 14, yes? Slide 14.
In the new slides.
I'm sorry, you're saying?
In the new slides.
In the D2 one, would you just look at my...
Yeah. Okay.
Since I'm doing screen sharing, if you need to write down something while I explain, please tell me, okay?
Okay.
So I'm skipping to page 14 because this is just what I'm saying. No? Using observables to determine things we cannot measure. We cannot measure temperature directly. We cannot go there and stick in a thermometer. We cannot measure luminosity. Again, we cannot go there and see. Correct? So what do? We use the observables. Observable is what we can measure here. Black body curve is the spectrum I was telling you about. here. Wait, we just go to spectrum thing. This thing, look. Whatever this means, this is the spectrum. Okay.
Okay.
I can measure this from Earth, so I'm going to use it to, for example, to find the temperature. I'm going to use it to find the temperature. Okay. As for the luminosity, actually, I'm going to use the apparent brightness. Okay? But I'm talking about this slide, actually talking what I'm talking about, right? Okay, yeah. So far, so good. Okay, I'm going to ignore this for a while. Okay, I'm going to ignore this for a while. I am going to also ignore this for a while, right? For a while. Option D, Hertz. Wait. Oh goodness me. Okay, fine. If you ever have, if you ever have to use this diagram, okay, sometimes your slide gives you something you have to use, sometimes maybe not, right? The point of this slide is if you have to use it, I can find there's a relationship between the luminosity, the real brightness, and its temperature, right? This is useful practically because you cannot measure luminosity directly and you cannot measure temperature directly. You cannot. Both is something that we seem to want, but we cannot do it directly. Make sense?
Yeah.
So if there's a relationship between them, then I will say, okay, if I can only just find the luminosity, which is hard to find, I can find the temperature quite easily though, using this diagram. It's nice because both I cannot do directly. Just something like that, okay? Just something like that. Okay? Just remember that this diagram exists because I'm not going to go through it very detailed yet. Yeah? Okay. Yeah, I'm just totally going to ignore this for now. Like just totally ignoring, like seriously ignoring all this for now, right? Yeah. And he wants to tell you about red giants. Okay, I'm just going to mention that our sun is very small. Look at that, right? Our sun is, I'm sorry, I should be using attention. Our sun is very small compared to a red giant. Obviously, a red giant is gigantic lah, compared to our sun. That's all. Okay. So one thing to note about the red giant is not just it is gigantic, but it is red. Sorry, obviously. I'm sorry. So if it is red, it is kind of cool. Cool as in cold, not cold. It's not very hot. It's not very hot. It's not very hot. What do I mean by that? I'm so sorry. Come on, show me. Show. Okay, for whatever reason, the astronomer noticed if the color is reddish, the temperature is this. This they call not very hot. This is obviously very hot for us, right? Obviously. Okay. Just for comparison, our sun is actually yellowish white. Our sun is much hotter than a red giant, even though a red giant is much bigger than our sun. Okay, there are reasons why they tell you this one, but it's very weird why they want to talk about this. So my point is our sun is here. They know that a red giant is red, and if a star is bluish, it's crazy hot. It's crazy. For now, that's it. Okay, that's it. Okay, let's go back to that slide. Red giant, tell me, red giant, where are you? They tell about Safed. Yes, wonderful. Where's the red giant? Is it here? Okay, so there's the red giant. I'm sorry, a red giant is smaller than a red supergiant. Okay, the point is there are so many big stars there. There's so many big stars, right? Okay, now a dwarf is the reverse of a giant. No, a dwarf is definitely smaller than our sun. Smaller. So our sun is not a sun is. Let's call our sun rather normal, because that's what we're used to, right? A white dwarf is white, meaning super hot, because white is hotter than blue. How do they know? They know, right? white dwarf, and the dwarf is very small. I'm going to show you something here which seems to matter for people in HL. I don't know why it's here. So a red giant will become a dwarf. A red giant will become a dwarf. That is what they actually know. They kind of just throw it random stuff and tell you this lah. So I'm gonna tell you that. Okay, red giant become dwarf. Don't know why. Don't know yet. Okay. So sorry, I'm teaching you random stuff, isn't it? Never mind. I'll teach you random stuff, but I'm gonna skip it. So make it even more random, right? Right. Yeah, this is a separate stuff, but my point is I want to tell you, they don't tell you why. remember the astronomers' obsession with distance. Don't know why we want to measure the distance even though we cannot go there. A Cepheid variable star is a star that we can estimate the distance quite easily. That's all. I'm waiting for them to demonstrate that, right? I'm waiting for them. If this doesn't happen, then I'll show you in the Cepheid and the Cepheid variable question. The Cepheid variable question will definitely ask you for the distance of the star one. Okay, okay, with a special method only a Cepheid variable can do. What is that special method? I don't see this slide, so I'll follow the slide for now. Okay, and then we go and tell you neutron. I'm gonna skip Pulsar. I'm gonna skip supernova.
All of this, like all these different types of stars. Do
Yes.
I just need to memorize like the properties and stuff? Or does it actually make a difference when it comes to solving questions?
Can I say something irresponsible?
Yeah, okay.
Yeah, no need lah. No need.
Okay.
This is not biology lah. Even if they ask you what's a supernova, let's say they ask you what's a supernova?
Yeah.
That's 1 mark though. Even if they ask, I don't think they will. This is really for fun, man. What's a Crab nebula? A Crab nebula is a supernova. Actually, a Crab nebula has a supernova in the center. How would you know? I mean, it's not obvious. It's not even obvious to you what a nebula is. And then supernova, what am I supposed to be seeing here? You know, something like that, you don't know. It's super random all the way. Please don't, please reserve your brain power for something else. Okay? Some other topic. That's why I keep skipping stuff. It's not that it's not interesting. Oh, I like it. I love it. I actually understand this stuff, but what the heck, right? Never mind. Never mind. Is this a supernova? Well, I guess he bothered to explain supernova remnant and what is N63A. He does not explain. Lies within a clumpy region of gas and dust in the large Magellanic Cloud. What is that? Like that, no? Just like that. Okay. Black hole. Black hole sounds important. Never mind. Nothing can be measured by them. Nothing. We are not smart enough at the A level to measure anything about the black hole. So never mind. Binary star. Do you see any binary star here? Do you see any binary star in the picture?
No. It looks like one.
I wouldn't be mad if you cannot see. This is the big brother and this is the little brother.
Oh, okay.
How would you know that's not a star that is bigger than the big one? Maybe that's a star so far from there. You should be at least asking that, right? Correct or not? How would you know? How would you know, astronomer? You cannot go there and see one what? You know what the answer is? The answer is they keep observing this and then they notice that this sometimes go behind and then sometimes appear again. That's what they observe.
Okay.
They observe the big guy, and then they notice a small guy, and then suddenly somebody say, wait, that small guy keeps appearing and disappearing. This must be a binary star, man. Because the if the star is very far from the big one, it will not appear and disappear. It will not do that one. But even if I explain to you,
Okay.
does it mean that you understand? Maybe not. Yeah. Okay, like let's say a binary star is a star consist of two stars, two sun orbiting around their center of mass. I explained to you that that means it's not either one of them, it's in the middle, right? A large percent of stars are part of at least a system with two stars. How would we know? Wait, never mind. Okay. Um, yeah, this English. Look, put another way, lah. You learn more when doing that question than when reading this slide, lah. Correct or not?
Okay. Yeah.
Let's just skip this. Okay, let's just skip this. Right? Let's just.
Okay.
Now, you know that this is important from doing question, not from reading it. Why do you want to bring lifetime here? Like what the... Okay, so random. Okay, Ananya, let's just remember that we see this formula and we do not know what it is, and I will make sure to mention it when we need it. Okay, I'll make sure.
Okay.
There is this formula. Nice. I am not gonna talk about that. Oh, finally, are we talking about Safik? Are we? Maybe. Are we? Maybe. Okay, nice. Madam Henrietta. Oh, sorry. Elliot. Oh, Elliot, I can see you. Can you see me, Elliot?
Yes.
Okay. Just a minute, Ananya. Just a minute. Ananya, would you kindly read the slide from there and ask me questions, right? Okay.
Okay.
Elliot, I make a mistake. I think I asked you to leave a bit earlier because I forget you start at 5:30, right? Right. So if you don't mind, we start earlier, right? So referring to the previous Jamboard. I'm just curious, Ananya. Is your teacher some sort of like a person who is very interested in astronomy? Do you think?
No, it's like it's an IB requirement to do an extra option chapter.
As in, when he explains the chapter, does it look excited, more excited than usual? Something like
No,
okay.
I don't think so.
All right. Okay. Okay, so Elliot. Elliot. I'm going to teach you a method which is not formula again, same thing, to find point S. You okay with me? We already find point Q. I'm going to teach you a method to find point S. Can?
Yes.
Okay. This is totally visual. This is not what your teacher will teach you. As per usual, I'm going to teach you something that complements that, makes it better. Makes your whatever your teacher is teaching better, right? So that's my goal here, right? So the method looks extremely simple. I'm going to draw a triangle. I'm going to draw another triangle. This true triangle is 90 degrees. Follow me so far?
Yes.
This triangle is exactly the same. The fancy name is congruent. Do you know why this true triangle is exactly the same?
No.
Because M is not just the middle of PR. This is a rhombus. M is also in the middle of QS. So far so good? Because, same side lah everywhere. So far so good?
Yes.
Therefore, since this is the same as that, this will be the same as that, and this will be the same as that. Do you follow?
Yes.
Key to finding S is to make full advantage of this. This distance will be the same as this. You can find S. This distance will be the same as this distance. You can find S. Do you visually understand this?
Can you repeat the last part?
One more time. Huh? I know Q right now, right? I know the full Q and the full M, correct? I know.
Yes.
I know this distance, therefore, yes, I know. Correct or not?
Yeah.
Therefore, it is the same as this one because the same triangle. Yes?
Yes.
Therefore, I know that half coordinate of x. Okay or not?
Yes.
I know this distance because I know Q and M. Therefore, I know this distance because they are same triangle. Therefore, I know the other half of S. Voila, I have S. Make sense?
Yeah.
Please try it. It's a very visual method. Okay, Ananya, back to the slide for now. Okay, look at your Jamboard, yeah? Ananya, so any questions on the slide that you have read?
No. Okay.
Yeah, so I'm back to slide 40 first, right? Because this is the start of how to use the suffix. Okay.
Yeah.
A suffix variable, let me state first, a suffix variable is not a variable like a math variable. No, a suffix variable is a star that varies in its luminosity. A star that glows up and down is a suffix variable star, so to speak. Okay. Secondly, a suffix is not a name. A suffix is a group. That means there are quite a lot of stars which suffix variable. I wish they would just call it a variable star. That just makes sense. It's a variable star that glows up and quite predictably. That is a suffix variable. Okay. This Madame Henrietta in 1912 figures out how to use it to our own advantage. In order to do what? To measure the thing that we are obsessed with. Okay, for some reason, he go and figure out the relationship between luminosity and temperature, which is the two things that we cannot measure directly. Okay. I'm sorry. Yeah, no, that's correct. That's correct. And then for some reason, we'll be able to use it for something else, right? Okay, so something, okay, yeah. So okay, I'm gonna show you how. Yes. There you go. Okay, there you go. Look. Finally, look. A 3-day period sulfate. Do you know what a 3-day period sulfate means?
It takes 2 days to
Glow up and down. It's not a binary star. This is really just staying there and glowing up and down.
Yeah. Okay.
Star does not do that. 3 days. For some reason, we can say a 3-day period sulfate has a absolute real thing, right? Luminosity, right? The thing that we always try to find, 800 times of the sun. Extremely useful because we know the luminosity of the sun. Extremely useful. So we know the luminosity of the sulfate simply by measuring its period. Again, why is it so useful? Because we can measure the sulfate from Earth, the period from Earth. We cannot measure the luminosity from Earth, never. We can measure the period from Earth. That's why. Okay.
Okay.
30-day sulfate, we can measure from Earth. The period is 10,000 times luminosity as by the sun. Very useful from the graph because we know the luminosity of the sun. Something like that. Okay. Something like that. And so you should expect that in your sulfate star question, you should expect to see this graph. I don't think you should be memorizing this graph. You should be expecting to have this graph and kind of use it. Understand?
Okay.
And never mind, this is something that you know. This mind maps just went bigger, but he's just going to add the separate variable here. Oh yeah, you're you are. Okay, summary, you're gonna ignore the last three methods. Your
Okay.
parallax is what you did just now, the one before.
Mhm.
Separate variable you just learned. And spectroscopic parallax, you kind of brush to a bit, but you haven't used. These three methods, by right, we are supposed to be able to use for our exam. The last three, not going to happen at all.
Okay.
This is how you measure that distances, right? And we should, we should stop here and try to do the separate one. I argue that's better. I argue.
Okay, sure.
Elliot, have you found S?
Yes.
Yes. What is S?
X is 5/2 and the Y is 3/2.
Let's see. Let's see. So, okay. Now let's start with the Y one first. Okay. Why is the Y 3.5? Okay. Because the M, so what's the M? So I have to write down the M. The M is this one, half, 3.5, correct?
Yeah.
Why is the S, the Y is 3.5?
Wait.
If it is 3.5, it will be the same as M. Visually, does that make sense?
No.
It should be higher than M. So again, twice. So try again. First time, visually. Okay, so try again. Ananya, I'm sorry. I'm basically asking you to paste the separate variable question in this chat.
Yeah, I'm finding it.
Sure thing.
Could you help me make it bigger, please?
I'm so sorry, Ananya.
Can you help me make it bigger?
Yes, please. So, Elliot, do you have a new answer?
Yes.
Okay, what is the new answer?
It's 5 and 7.
5 and 7. Okay. I think the 7 we agree. 3.5 times 2, right? 3.5 plus 3.5, right? Makes sense, yeah. Ananya, never mind the defined luminosity and apparent brightness. I think you should check the answer key to memorize the fancy words, right? Because you already understand. Just memorize the fancy words. If you think the fancy word doesn't make sense, you must ask me. Okay. Oh dear. I'm gonna ask you to ignore B for a while. I'm gonna ask you to try. This separate question is a little bit weird, isn't it? Well, they do tell you this, right? I'm going to focus on this one is wrong. This is a typo. This must be 10 to the power 29. Okay. They tell you luminosity is a very rare question that tells you luminosity at the start. Okay, so they tell you apparent brightness. So apparent brightness and which is B lah, right? And luminosity. is related. So this is so weird. Okay, so I'm going to challenge you, Ananya, for this, the last question of the day. Can you go and solve part D1? Would you please trade a little bit? Okay, 5%.
D1.
Yep, D1. The one
Oh,
in the...
D1. Okay.
So Elliot, your new answer is 5. Am I correct? 5, 7, right?
Yes.
Now, why is it 5 according to you?
I mean, I don't think it's 5 anymore.
Okay. Is it an ugly number? Is that why you're having trouble?
No. But
What is it? What is it? What's your new guess?
my new guess is 3.
3. Okay, let's go 3. Okay. Now, I'll show you how I do it, and then you see whether is it actually 3 or not, because I don't know how you do it, right? Okay, for now. I'm going to calculate this distance lah, because I can use it here. Make sense?
Yes.
This distance is, keep it simple, it's 6 over 5 plus half low. It's not a very nice number. Would you help me press the calculator for that? 6.5 plus 6 over 5 plus half. What is that?
17 over 10.
Okay, 17 over 10. So this distance is 17 over 10, which is we're at 1.7. So I believe this distance is also 17 over 10. So I believe S should be half plus 17 over 10. A very ugly number. Yeah, lah, but I believe that should be the answer. Does that make any sense to you?
Yes.
Okay, so it's slightly less than 3 lah. It is slightly less than 3. Now, I have another reason why I think 3 is wrong. I have a reason. The reason is visual. Look at that. You get what I'm saying?
Yes.
The R is 3 here. How can the S be 3? According to the graph, a picture, the S should be slightly to the left. It should be smaller than 3 if the picture is not bluffing us, which I don't think they're allowed to do. They cannot bluff us. You understand me?
Yeah.
That's why I think my answer is slightly better than yours, even though it might not be correct. But I have my reasons, no? A visual reason. You understand?
Yes.
Okay. I'm quite happy teaching you the visual stuff. If you have no question, I'll go to your Google Drive, go get one CG question and paste it here. Can you do that?
My Google Drive.
Sorry, whatever I have shared to you, I've shared you some, some math paper, right? Have I done that? Sorry, have I done that, Elliot? I have shared your Google some math paper through the Google. I have never
paste the question like from the math paper.
Yeah. If you go to the math paper I share, there will always be a CG question. It's very obvious which one. Go and copy and paste it. Can you do that? Okay, at this point, Ananya, if you decided that's how we do it, then let's see whether it's correct or not, just based on the answer key. Like, okay.
Can I just check the answer key for the method?
I'm sorry, you're saying? Sorry?
I'll just check the answer key to see if the method is correct.
Yes, please. Yes, please. No, yes. That's why I asked. Elliot, are you okay?
No, I couldn't hear it. I couldn't hear you just now.
Elliot, are you okay?
Yeah.
Okay. You have trouble finding the paper, please tell me. Yeah?
Yes. I couldn't hear you at all after that. Then I can hear you.
Yes, I do notice the audio seems a little bit bad also on our side. Thank you for telling. Let's be aware. Let's be aware.
Yeah, the answer is correct.
Okay.
The method is correct.
So that means you suddenly understand this formula, I guess. Yep. You are asking.
Okay. Yeah.
Let me underscore, however, that this formula is not a special Cepheid formula. This formula applies for everything and everybody. If you know the luminosity and you know the apparent brightness, obviously you know the distance. Obviously what? That's for every star, not just for a Cepheid, if that makes some sense.
Yeah. Okay.
This question seems to be Cepheid in a way that all the explanation part, not the calculation part. I was expecting the calculation to use the special graph for Cepheid, the connection one, and I don't see it here. And turns out that we don't use that for some reason. I don't know why the question is like that. It's
the luminosity relationship one.
A relationship, which I was telling you from this. I was looking for that. In this. Okay, we found it today. So I was expecting them to give it here. He does not give it here, and he therefore cannot ask you to use it. This simply becomes a formula which is valid for every other star, not just Cepheid. Just want to say that. The rest, A, B, C1, C2, and D2 is based on our qualitative understanding of Cepheid lah, right? I tried to explain to you very fast just now. If you don't understand the answer key, please tell me, something like that. If you want me to explain the A, B, C1, C2, I can explain it rather fast right now. Would you like me to do that?
For this question?
For this question.
Okay, sure.
Right. So for some strange reason, I feel that we should start at D2 lah. Cepheid are sometimes referred as standard candles, right? Standard candles means a candle that we know. The candle obviously refers to a sun. So it's a standard star, star, meaning a star that we can know the luminosity beforehand. It is a star that we can find the luminosity quite easily, so to speak, quite easily. Okay. Because that is the importance of the Cepheid variable. That's why important. So the Henrietta Madame found that relationship. So a standard candle means I am now going to use that advantage. The Cepheid star, we know the distance. That means I'm able to find the distances of other star near the Cepheid, so to speak. That is what using it as a standard candle means. I can kind of figure out the rest nearby because the Cepheid I know. Something like that.
Okay.
So that's my simple way of explaining. Your answer key will give you a fancier way of explaining. I'll leave it to the answer key. And yeah. For C part 2. The Cepheid variable for estimating distance to galaxies. So, oh goodness me, that's just the same thing. Okay. First of all, I can find the distance to the Cepheid variable by the special relationship that it has, right? Okay, the one that Madame Henrietta found. Okay, once I do that, I can try to figure out. The galaxy has many stars. I don't know, 10 billion stars. Among the 10 billion stars, maybe there are, in general, I don't know, let's say 100 Cepheid variables in that galaxy. It's not just one, it's around 100, spread rather nicely across the galaxy. Making any sense so far? Since I have these distances, I can kind of average it. I can kind of average their distance into a center one. Do the same thing to another galaxy, right? Another galaxy will also have its own Cepheid. Just average it, and then this point and this point will be the distance between two galaxies. Because when we want to measure distance between galaxies, we go from one center to another center. Cepheid is very helpful in doing that. The other star definitely not, because we cannot figure out their distances, so to speak.
Okay.
That is my simple way of explaining. I will see you on Sunday, right, Anya?
Yeah.
Is that a good day to see you, considering that you will have exam tomorrow, lah? Something like that, right? The day after Sunday, lah.
Saturday.
I cannot see you on Saturday. When's the physics?
Okay.
When is the physics exam?
The physics paper is on 4th July, Tuesday, like next week, Tuesday.
So same thing with Daniel. Daniel also, I usually see Daniel on Sunday also, and this Sunday definitely not, because he has to focus on other exam. That just makes sense, right? We should do. Why don't you adjust your, the Sunday time to another day where you have less thing to worry about? Am I making any sense?
Yeah.
Don't adjust it to Saturday or Friday, because simply I cannot do it on Friday and Saturday. Right?
Okay.
Would you want to decide now, or you want to think about it first?
What about next Thursday? I think it's a public holiday, so I will have to.
Let's do Thursday then. All right. I'll see you on Thursday.
Okay.
Okay.
Okay, thank you.
I'll see you.
Bye-bye.
Elliot, now I'm back. You don't have the paper yet. You don't have the paper yet. You don't have. Is it difficult to find the question?
I don't know what's the paper.
Okay, I cannot hear you very well. Sorry.
I don't know what's the paper.
You don't have the sorry, I don't get that. I'm sorry. I have never shared with you papers, correct?
Yes.
Oh goodness me, sorry. That's not good. Although you can get questions from your textbook, sometimes you should, right? Sometimes you should simply get question from textbook. That's how you've been doing your homework. But if I want you to get it from paper, that means I want to say, okay, here's an exam level question. You can be certain if you can do this, you're quite okay, right? Something like that. Okay. So stop my sharing for a while. Just a minute. Okay. Kakak Brian, can you hear me?
Yeah.
So Kakak Brian, as per usual, sometimes this happen. So I think 2% cancel this Thursday. They give their own reason. It's a holiday. Yeah. So suddenly we are not very crowded. I mean, but stay here. What else to do? That's just how it is, right? That's just how it is. Right. Okay. I'm in the middle of explaining the CG question to Elliot, or something.
Okay.
Right. So the binomial, he did cover quite a lot of good and difficult stuff. Yesterday, he did two difficult ones. The power n one and the trinomial one. Right. So yeah. So next time you see Elliot, you should expect that he can do it in the sense that he should have some idea, right? Okay. So Elliot, something like that. I have now shared with you Sec 3A math. Would you kindly go to your drive and see whether you have Sec 3A math with you? If you don't know what's going on, please tell me. Please tell me. Yeah, please tell me if you don't know.
Yeah, I have it.
Good, good, good. So choose a, I believe, don't choose a SA1, choose a SA2, right? CG should be an SA2. Just choose SA2. Tell me which paper are you looking at?
Fairfield Methodist, the 2014.
2014 SA2 Fairfield. Okay, let me confirm that this is not what I used just now. Okay. Okay, this is what we, oh. Oops, I think this is what we used just now. So don't do that. This is the paper that we used just now. So that was the question. Another one, please.
You'll go for the next one.
Oh, all right, let's go to Hilgrom. Hilgrom, come. You go find the CG question by yourself. Give it a try. See whether you can spot it.
I put it in the Jamboard.
Yes, please. Copy and paste. Put it in the Jamboard. I'll see you in the Jamboard. Surprisingly, that is not a CG question. Very surprisingly.
It's the first question that I see.
It does look like it. I agree with you. It does look like it. But until you learn this, this will not happen. Now, how do I know this is not a CG question? Very simple. Because the axes are weird. The axes are called LGX and LGY. Extremely weird. Right? Once you learn this chapter, you will know what is going on. But this one is not. There is another one, definitely. Please take a look.
Got another question now, but I don't know. Wait.
Which number? Which number?
These are the last two questions.
So the other question is number?
10, 9.
Please paste that. Please paste that. I'm gonna delete this one for now because this one you cannot understand right now. Okay. This one, the axis is not weird. The axis is simply y and x. Yes. Okay.
Yeah.
This one, I think, is a CG question. Yeah, I think it's a CG question. Now, remember the habit in CG question, the picture is more important than the English. Now, what that basically means is just make sure that all the English is in the picture. That's one good way of understanding the picture. Please do that right now.
Do what?
Make sure that the English is on the picture. So, trapezium OWXY, is it the picture?
Yes.
Which one is OWXY? Let me confirm. Which one? Please draw it for me.
This one.
Use a laser pointer. Yeah, okay, very nice. Yeah, okay, something like that. Just to confirm, is that a trapezium? Yes, no, not sure. Yes, no, not sure. Trapezium?
Not sure.
Okay, a bit of a problem. Draw a trapezium for us, please. What do you think is a trapezium? Nice. Okay, nice. Okay. I want you to draw very correct, very correctly, like for example, if I draw a parallelogram, let's say, for example, I draw a parallelogram, then I'll make sure to do this, right? Do this, and because this is the defining feature of a parallelogram, right? Something like that. If I do draw a rectangle, because our drawing is not perfect, I'll make sure to do this so that the one looking at it at least know it's a rectangle, because again, our drawing is not perfect. Now, for a trapezium, is this all totally random, or is there something defining? Wonderful. This is, I agree, a trapezium. I totally agree. Look at this for a while. Trapezium or not?
Got right angle there.
Yes. So let me explain so that so that we remember. This side and this side, I totally agree that this should be parallel. That should be a trapezium. This side and this side, if I make them parallel, they become parallelogram lah. Make sense? They are no longer a trapezium, no? Correct?
Yes.
So how do I make a trapezium? It's very simple. I'm gonna make one of the parallelogram, no longer parallel. So for example, this side, right? I'm going to now make this side just slightly less parallel. Now, that is a trapezium. A trapezium is a parallelogram, but only one side parallel, the other side not parallel. Am I making any sense so far?
Yes.
So, based on that definition, here's another possible line. Is that a trapezium or not?
Yes.
Based on that definition, is this a trapezium or not?
Yes.
Correct. That's what you draw. Lo. You draw the third option, fair. Lo. He draw the second option, also fair one. I can also draw the first option and call it a trapezium. No problem. Am I making any sense right now?
Yes.
Okay. So what he draw, is it a trapezium?
Yes.
Now, why is this very important in your reading? If you just read trapezium and you don't see the picture as trapezium, it is terribly, terribly not okay. It's terribly not okay. They will keep using shape one. The first guy used rhombus. The second guy used trapezium. Then maybe the third guy used parallelogram or use cube or whatever. That's how they do CG. They will import a shape from emath. Okay, so far?
Yeah.
You have to master the shape. It is, however, an emath shape. It is something that you already know. You just have to refresh a bit, right? Sometimes they give you a kite based on emath, for example. Now, why is it important for you to realize this is trapezium? Is because you will feel better making use of this 90 degree, and you will feel better making use of this parallel, so to speak. And later on, if they ask you for area, this one don't, but if they ask you for area, you will hopefully also find it easier to find the area, if that makes sense to you.
Okay.
Yeah. So the trapezium, realizing how is it a trapezium is an important thing in our reading of the question. Okay. Now, this one, is it in the question? Is it in the picture?
Yes.
Okay. This one, is it in the picture?
Yes.
Is it in the picture?
Yeah.
Is this in the picture?
Yes.
Yes or no?
Yeah.
Yeah. So you can ignore this from now on. Correct? Right. The picture is there. Now, I guess I did teach you to ignore the sentence part, the question part. Right? But for this question, we're just going to give it a try. Right? So remember, please remember I'm teaching you just now. Yeah. So finding the line y-axis, right? I teach you what are the things you need to find a line. What is it?
I need the gradient.
You can, okay, that's not enough. You must say, I need gradient and one more thing. What is it?
The coordinates.
Okay, I need a point, but currently it's called a point and a gradient, no? Or another option is? Come on. Another option is? There are at least two options here. Okay, Elliot, listen to me, see whether it makes sense or not. Or I can have 2 points. Am I making any sense, Elliot?
2 points is in 2 different coordinates or what?
That's what it means by up.
Elliot, where were we on now? Where was he on?
We use the same Jamboard as the last time.
Last time. Is it shared with me already?
Yeah, I think so.
What's the name? 28 May.
Yeah, 28 May.
Okay. Page 14. Okay. Which part was he on?
Right, he was explaining the different ways to find a line or something.
Like, is he going through the pre-part A or like what part is he going through? Or like, do you know where he stopped?
I said like need have the gradient and like the coordinate to find the line.
To find the
Then
line.
like
Okay.
still got one more. Then after that,
Hello? Sorry, you got cut off.
hello?
Hello? Yeah. You got cut off just now.
Yeah, about I say the what gradient and coordinates to find the line.
Correct. Yeah. Do you know do you know what's the formula? Like the equation?
Is it not the y equals mx plus c?
There's another one we learned, right? Do you know? There's the y minus y1 equals to
Oh yeah.
x minus x1 lah. So there's two lah, right? So both works, right? If as long as you have the coordinates, then you can find, right?
Yeah.
But part two, the second one is you need to find the c lah. So that's the only difference, right?
Yeah.
So which diagram was he drawing on now?
He's drawing on this one. The blue line.
This one. This
Yeah.
one.
Yes.
So okay. So do we have the Okay, what do we not have? So what do we need? Do you know what do we need?
We need the gradient.
Gradient. So how do we get a gradient? What's the gradient formula?
Y2 minus Y1 over x2 minus x1.
Okay, so we have coordinate y, which provides us with y1 and x1, right?
Yes.
But that's not enough, right? We need y2 and x2. So how do we get y2 or x2?
The one I don't know.
Sorry?
I don't know.
Oh, okay. Are you like new to CG or something? Is it?
Just started today.
Okay, can. So OW XY. Okay, wait. Okay. So right, to find now we have 1 point, but we need a second point, right? And then based on this line, there's only 2 other points that we can use lah, X and Z lah, right?
Yeah.
But then right, so here's the thing. Now that we know that OW and YZ is parallel, right? That means OY, the length must be equals to WZ, correct?
Yeah.
Because it's parallel lah. So obviously the length must be exactly the same, right? So
Yes.
what's the length of OY?
5.
5, right? So do you know where I'm going with this? If I know OY is 5, what do you think WZ will be?
Also 5.
5 also, right? So what should Z be in this case? What would the X coordinate of Z be?
9.
9, are you sure?
Wait, no. 7.
7. So that's the X coordinate. How about the Y coordinate?
Should be 4.
4, right? Why do you think it's 4?
Because W and Z is on the same
Hmm.
level.
Wait, OWYX. It's very hard to say. Yeah, I mean, based on the diagram, we can assume it to be like that lah. But by right, they should give more clues on whether or not it's on the same line lah. Because if the diagram is not like drawn to scale, right, then the thing might not actually be a straight line lah, right? It could look like a straight line to us, but it's not. You get what I mean?
Yeah.
So there's no really way to know this. Yeah, there is actually like not really much ways to know this lah. Okay. So okay, so let us, now that we have point Z, right? Would it help to find the gradient or will it not help?
Oh, will help.
Okay, so what's the gradient now? M equals to M equals to
4 over
sorry?
over
Not minus anything, man.
oh yeah, 4 minus 0,
Okay.
then over 7 minus 5.
Which is 4 over 2, which is 2 lah. Okay, so now we have gradient, we have coordinates. Are we able to find the equation?
Yes.
Yeah. Wait, yes. Okay. So right, it's a bit dumb lah, this question. So in a sense that I don't think it's very well made lah. So they said that yx is parallel, right? Yx is only this portion, right?
Yeah.
So technically, right, we cannot assume that yz is parallel to OW, right? Because it could be like that, parallel, right? Then this one branch out a bit, but we cannot see lah. But then I guess that's why they give you the perpendicular maybe. Because if this is perpendicular, this must be perpendicular lah. So it has to be parallel lah. Okay.
Yeah.
Okay, so now, but then right, we only have the gradient, but we don't have the. Oh wait, since the line is parallel, then it's the same line lah. No, it's not the same line. So yeah, because they want the line equation of line x, yx, right? We cannot use the points. Okay, never mind. Screw what I said. Okay, now you know these two equation, right? You wanna use which equation?
Y equals mx plus c.
Is it because you're more comfortable with that, or like
Because I've never seen the top equation.
you never seen the top equation before?
No, I don't think so.
Okay, I mean that's a formula I think you will learn in A math lah. So we'll use the top equation lah, because you have to learn it eventually and get used to it lah. Okay.
Yeah.
So what it means, right, is this y and this x, they are just random algebra. So y minus y1 and x1 means a certain like coordinate lah. So in this case, we'll use point y. Do you think we can use point z, or can we only use point y?
Oh. Only point y.
Why do you think z cannot be used?
Because they ask for line yx.
Good. Okay. So y minus y1. Y1, right, in this case will be 0, because that's the y coordinate of point y lah, right?
Yeah.
Then gradient is 2 bracket x minus 5, right? So now it's y equals to minus 10. Yeah. Do you get it?
Yeah.
Yeah. So that's the way to. So like you don't have to waste the extra step on plus C lah. And they will teach you this in when you learn this topic lor.
Okay, thank you very much for picking it up, Kakak Brian. And sorry, Elliot, I accidentally logged out. Right. Okay. Elliot, I guess Elliot. Elliot, tell me, where are we right now?
I think we finished part A.
Fine. All right. You tell me, how is it done by English lah? What do you do first? What do you do later? What did you do?
Find the point Z.
Find the point. What? Sorry, because your voice. Sorry. Let me wear my headset. Your voice is not very good. Okay, let me try that. Right. Okay. Yes. Please try that again, Elliot.
Find point Z.
Find point Z. Okay. How do you do that?
Like visually.
I'm sorry. Try that again. I cannot hear you.
Visually, you see, then like you calculate out.
Okay. I understand. I understand what I'm saying. Okay. Find point Z, and then what?
Then find the gradient.
Okay, and then?
And then use the equation.
Right, and you can follow that.
Yes.
Yeah. Okay. Now, here is a surprise. Here's a surprise, huh? Sorry, yeah, before I explain this, I don't think the question is good this way, yeah. Okay, I don't think the question is good this way. Now let me explain. I think this is the fault of the question. Okay. If I look at the question, I have a feeling that Z is not allowed to be used until part D. Okay. How come I have that feeling? It's a feeling, right? Because Z is only mentioned at part D, obviously, but more importantly, he only tells you that OWZY is a parallelogram at part D. However, you cannot be blamed to use Z because they never forbid you to use Z. That's one thing. They never forbid you to use. So it's a very gray area here. But if the teacher is very strict, he will say, yeah, I know there's a Z there, but you do not know it's a parallelogram one because at the start, they never say. They never say. The gray area is that I can read below what? I can read below and nobody can actually stop me from using it on top. So it's based on strictness. They haven't told you it's a parallelogram, but you can always read below and use it. This is not a problem you are supposed to have. A question shouldn't be ambiguous like this. Do you understand what I'm saying, Elliot?
Yeah.
Okay. Now, for the sake of practice then, okay, for the sake of practice, I will now say that D never exists at all, and therefore Z does not exist at all. Okay. Even though the teacher may be strict, let's say there's a strict teacher and he forbids, no, you just cannot. But teacher, I can read below. You just cannot. Let's say he's being strict. But in reality, the teacher knows the essence of the question. The question wants you to not use Z until later. It's just a bonus question. Meaning to say, you can actually find YX without Z. So for today's learning, let's just treat it as an additional challenge. Let's not use Z and find another way to find equation YX. You get me, Elliot?
Yes.
Okay. There is nothing wrong with using it if it's written. That is, however, my argument. But my argument is actually a question shouldn't be written like this. It's bad. It's bad. Okay. Yeah. So I'm not blaming you to use Z. Not at all. Right? Not at all. That's not the point. Now, I told you, like Elliot, you want to find YX. You look at the second question. He asks you to find coordinate X. I teach you what that means. What does that mean? What does that mean, Elliot? Elliot, you forget already, is it?
Yeah.
Okay, look at the previous question. Previous question, yeah? The previous question, if you want to look at the question, find equation QS, and then later on find Q and find S. So what does that mean actually? Hey, come on, Elliot. Come on, come on. How did you find QS in this question? The previous one?
Because what half the coordinate then sum inside.
Oh dear. How did you find equation QS? You forgot already, is it?
No, find the line of the gradient.
Okay,
You
okay.
find a line.
So did you use Q and S to find QS?
No.
Okay, good. How do you know? Because the question is structured that way. The question is find QS first, then go and find Q and go and find S. So actually QS cannot be used to find QS. Make sense?
Yes.
Okay, now back to the current question. So find xy, yx, sorry, and then go and find x. What does that mean? You cannot use x in finding yx. Do you understand?
Yes.
So there is no point in trying to find x right now. That will lead you totally nowhere. There must be another way to find line yx. Now that will be the question. Now this line, however, you have 1 point already, right? 1 point already. So I keep reminding you that to find a line, you either need 2 points, but you cannot. The other option is to find the what is that? The 1 point and
the parallel one.
the gradient. Okay, so there is a parallel. So this is parallel means the gradient of this line is equal to the gradient of. Okay, your voice is very bad. So would you please use a laser pointer or something? It's a bit difficult to communicate.
Then it's the same as this one.
Which line? Which line? Yeah, okay, very nice. Now, can you find the gradient of this line actually? If you can, oh, okay. How would you find it?
You got both coordinates on.
Oh, really? Which coordinate that you know? Which other coordinate do you know? Okay. Okay. Wonderful. Wonderful. Right. So again, tell me what is the rise visually?
The rise is 4.
Wonderful. The run is? What's the doubt? Why is there a doubt here? Sorry. The run is?
2.
2. Now, there's a reason maybe why you're doubtful is because this 4 looks shorter than this 2. Am I correct? The 4 looks shorter than the 2.
Yes.
Okay. That should confuse us, and this is why the question always say this is not by scaling. So can the question confuse you this way? Kind of. The question is allowed to confuse you this way. Okay. Furthermore, this is 2 and this is 5. The 2 looks too near to 5. Correct or not? It doesn't look right.
Yeah.
Is the question allowed to do this? Well, kind of. What the question is not allowed is to draw a 2 here at the right of 5. That's not allowed. But the scaling a bit wrong. The question is allowed to do that. Can you? Yeah. So it kind of makes us a bit uncertain. Is this really 4 and is this really 2? So in that case, we rely on the number and you got it correct. So 4 over 2 is what you get from the previous method. Well, happy. We could have found it using this gradient. We also could have found it using z. That's nice. The next process is just the same thing. Can you?
Yeah.
Okay. So now yx is done. Yx is done. Okay. So good job, Elliot, and good job, Kakak Brian. Now, how would you find x, Elliot? Explain instead of doing it. Oh, it's not going to be very easy. Okay, never mind. I'm going to have to explain to you, right? Okay. Now, more importantly than finding a line is finding a point. You have to know many methods. Now, I'm going to introduce to you. Well, I don't say it's a new method, but it's new for today, right? I have this line. If only I have this line, I will be able to find x. That means I can find a point by intersecting 2 lines. That makes some sense, yeah?
Yes.
The question is, do I really have this line? Currently, I don't have. Do I really have it? Now, what do you think, Elliot? Have or not? Here, you must think about, do I have the ingredient for the line? I don't mean that, do you have the line? Obviously, you don't have the line, but do you have ingredient for the line? What do you think? What do you have that you can use to find this line? Come on, Elliot, say something, Elliot. Come on. Are you okay, Elliot? Can you hear me?
Yeah.
WX, please. Do you have any ingredient for that line?
No, just don't have one.
Well, I mean, I think I have 1 point. Let me get any sense here. But this one I'm teaching. Right? This line, come on, Elliot, let's repeat this together, yeah? To find a line, we either need 2 points or we need 1 point and a gradient. Any combination is fine, correct?
Yeah.
So, do we have 2 points or do we have 1 point and a gradient? If we don't have both, then at least tell me what we have.
Have 1 point.
Okay, that's nice. So either another point or another gradient, right? Another
Yes.
gradient. And I don't think we will be able to find this point. I'm very sure of it. Do you know why?
Why?
Because that's the question. I'm trying to use this to find this point. Therefore, I cannot rely on this point. That point must be found later, not right now. Am I making any sense?
Yes.
So just like that, I've eliminated my options. Oh, I think I should go for the gradient route. I already have a point. I wonder whether I have this gradient or not. That kind of helps if you think that way. Am I making any sense?
Yeah.
So do you think we have the gradient of this line? How can we find the gradient of that line? Maybe I'll put it. I'll give you a hint. Ring a bell?
What perpendicular line?
Yeah. It's something new just now, right? Do you remember? If I have this gradient, I can find the perpendicular gradient. Do you still remember how to do it? This gradient is 2. So this gradient must be what? Remember just now we just flip. I cannot hear you. Can you speak like normally? Maybe use a normal headset or something. It feels like it's very off this last session. Like maybe you're just using something different. Maybe.
I'm not using a headset for like all the lessons.
So this
Now
is like a normal setup, is it? This is your normal
Yes.
setup. Why it's so bad? Let me check that. Maybe it's my fault. Kakak Brian, do you think Elliot's voice is as normal?
Like sometimes it's clear, but most of the times it's like a bit off, like cannot hear.
Is this different than usual, I guess?
Yeah. I think the mic maybe got issue.
What's going
It's
on?
different.
Okay, but Elliot, you're saying that you're not using a headset, right? This is just your normal phone, is it? Normal phone, is it? No.
Yes.
Hey, you're not okay, Leh? Try again, Try again, Hey, you're not okay, Leh? Because I don't want you to scream and shout. That's very bad. Okay, tell me, this is gradient 2. This gradient is what, Leh? You can refer to the previous page, right? If you remember that we were doing this, you can at least refer, right? Okay, so if you look at the previous question, okay, screen sharing, yeah, look at the screen sharing. So never mind, I just yeah, okay. So if this gradient is 2, remember we flip the fraction and we flip the sign. Okay, so please do that for me, Elliot. If this is gradient 2, then this gradient will be Flip the fraction, flip the sign.
-2/4.
Flip the fraction, don't forget the sign is flipped. Okay.
Huh?
Try again, Elliot, because sometimes I cannot hear you. So the sign is negative, and then the fraction is become
2/4.
okay, 2/4, right? 4/2, 2/4, which is half, correct? Half. Okay, I think because I cannot hear you just now, right? So the gradient is minus half. Now, do we have this line?
Yes.
Okay, now if we have this line and we have this line, we can find this x. Okay, now it's time to simply do it lah. Okay, let's move to the next page. Okay, please do it in the next page. Oh, sorry. I'm sorry. Just use the normal video, please. Just use a paper, right? I want you to do a paper and I want you to do it normally on paper, right? Okay. Go and find the line, please. Okay, so I can follow. Okay, good.
Can I draw the line on the diagram?
Of course you can draw the line diagram. What do you mean? Of course you can. Of course you can. Of course you can. You can do anything with the diagram. Okay, nice. Okay. All right. Okay. Right. Okay. What line are you trying to find, Elliot, right now?
Mostly, because if I use the method, the last page on the page 13, then got the two triangles. But this one,
Yeah, this one I tell you first. I don't explain why. The two triangle method is not doable here because, frankly speaking, it is not obvious where the two triangles are.
Yeah.
Okay, but there are multiple methods. I'm trying to get you used to. Don't use just the triangle one. This one is not possible, but we talked about it just now, right? To find a line, Because the triangle method is not to find a line, it is to find a point. Understand? What are we trying to do here? Finding a line or finding a point right now?
Finding a point.
Wonderful. X. By crossing two lines. Correct?
Yes.
We are trying to find the second line before we can cross it. Correct?
Yeah.
So what line are we trying to find right now? Uh-oh, we're in some trouble, isn't it? Sorry, Elliot. Do you know what line are we trying to find right now?
I thought we found the WX line already, but
How come we have found the WX? How did we do that?
did you not find that just now?
I thought just now in part A, we found the equation YX, right? That's for part A, right?
Yeah.
Did we actually find equation WX, really? Where is it then? Where is it? I mean, we discussed how to find it, but we have not find it, right?
We have just gradient.
Hello? Yeah, just the gradient. Yeah, there's no C, right? There's no C. Right. Remember the thinking, Elliot? Let me form your thinking. We need a point and a gradient. You should be using your point, right? You should be using your point. You should be using your point in order to help you complete the line. Oh dear. I guess we can do this method. I'm sorry. Yeah, okay. I won't contradict you. I won't contradict you. Okay, okay. Yeah. We can use this method. That's fine. Right. Now, so that you're used to it, Elliot, your method is definitely correct. Okay, so that you're used to it, would you try subbing in the y and the x directly to the ymx plus c? Try that. See what happens. Do you understand what I'm saying?
Yeah.
Okay. So try two ways so that you know that there are two ways. Hopefully, and then you have options lah. You have options in case the question feels a bit weird. Feels a bit okay. You still put in the minus half. So because you know the minus half already, right? Put in the y, yeah, and then put in the minus half since you know. Put in the x, right? Put in the x. Put in the x. You know the x. You know what I'm talking about. You know the x. You know the x, not the c.
Right.
Correct. You know the x. Yes. Okay, then plus c lah, right? Okay, now can we find the c? Is it the same or not? Let's try. Okay, now Elliot, which one is superior?
superior as in what?
Up to you lah. Subjectively lah.
Very easier is the YMX plus C.
Right. Now, does that mean we can simply forget the first one?
For this question, yes.
For this question only, but we never learn just for this question one. In general lah.
Then no.
I believe so. Please remember that there are two methods. Just so happen this question easier the second one. Just so happen. In other question, the first one might be easier or might be more appropriate. We wouldn't know lah. We wouldn't know. Okay. There are many methods to find a line. There are many methods to find a point, and there are, yeah, there you go lah. There are many methods. Keep them in your mind. Hopefully, that's not very confusing. Okay. Okay. Keep them in mind. Yeah. Now we already found two lines. Do you know how to cross two lines in order to find a point?
Cross. Did you say cross two lines, find a point?
Yes, that is what I say. Yes. Do you understand what that means actually?
No.
All right, then let me show you. We know yx, right? There you go. That's yx, right? You found it with Kakak Brian, correct? That's your yx lah. Okay. You know wx. So how are we supposed to use that? Look at that. Look at that. I want you to look at mathematically. Maybe it'll ring some bell. I have this. I have that. Do you see any way to make use of both of them so that you find x? Do you see any way? Oh, this question is very terrible. Wow. For Kakak Brian. So I'm speaking to Kakak Brian for. Kakak Brian, this question is very terrible, isn't it? First of all, I realized that they shouldn't be using x and y as a point. It's very bad, isn't it?
Yeah.
It's extremely confusing for the student, right?
Right, yeah.
Terrible, you know, this question very terrible. Elliot, this question is very terrible. Oh my goodness. Terrible. Not a good one. Not good. Still, we can make use of it. Elliot, any idea how to use both of them together? Both of them? Well, doesn't that look like a rather easy simultaneous equation? Don't you think? Ring any bell? Simultaneous equation?
Yes. Yeah.
Can you simultaneous equation and, well, find something?
Can try out.
Can try. Please try. You're an A-math student. Certainly you can do this. Kakak Brian, can you help Elliot for a while? I have to get something.
Oh yeah, sure.
Okay, thank you.
Sorry. We are trying to do part B, right, Elliot?
Yeah.
Okay, so I believe what I was hearing is like we have the two lines, right? The y equals negative half is the wx, right? Is it? Sorry, what y equals negative half x plus 5.
That's the gradient of that line.
The wx lah, is it?
Yeah, wx.
Okay, then we have yx, which is the y equals 2x minus 10, right? Correct? Is that the other line we have?
Yeah.
So how do we find x if we have these two lines?
Basically, simultaneous equation.
Why is it simultaneous equation? Because the lines, what's that word?
Intersect.
Point x is the intersection lah, right? Meaning that the wx equals to yx at point x lah, right?
Yeah.
So that's why you use simultaneous equation lor. That you understand, right?
Yeah.
Then do you know how to do? I mean, it's just quite simple simultaneous, right?
Yes.
Okay.
Is this correct?
You just simultaneously, right?
Yeah.
Let me see if it's correct. Is it 2.5?
Yes.
Wait, 5 plus 10, 15, 11. Do you have the answers for this? Okay, I mean, we check at the end, no? I mean, I think it's correct. I check personally, it's okay.
Do I check the answer?
Sorry?
You got answer sheet up.
No, it's okay. We just continue first. So, coordinates of x, quite easy to find, right?
Yeah.
Okay, so now we're on part C. So find the perimeter of OWXY given your answers in the form of blah, blah, blah. So perimeter means they want the length, right? Length plus length plus length plus the length, right? So we break it down into 4 different lines lah, right? Oh, sorry, let me find okay. We'll break it into 4 different lines. We have to use we'll have to use OW, O. Sorry, wait. So OWXY. So there is O. Oh, why is it black? OW, which we know is 2, 4, and 0, 0, right?
Yeah.
And WX, which we know is 2, 4, and sorry, what's the line we find just now?
Six and 2.
Okay, 6, 2. Then OY, which we know is 0, 0, and 5, 0. And finally, what am I missing? Oh, YX. YX, which we know is 5, 0, and 6. Do you know how to find the length of a line? Has Gafe taught you that?
No, haven't.
Oh,
Haven't.
so we
Yeah.
go through.
Yeah, but phrase it as a Pythagoras, can?
Yeah, correct. Okay.
Yeah, bit, yeah. Okay, I'm just back. Yeah.
You want me
Please,
to go through or you go through?
please help explain the Pythagoras one. Yeah.
Sorry?
Please help explain using the Pythagoras.
Okay, yeah, sure. So you see now we have 4 different lines, right? And you can tell that like 3 of them is like slanted lah, because the Y is different, right?
Yeah.
But so maybe we can first find the length of OY lah, which is quite easy lah. And I think just now at the start, we already say it's like 5 lah, right?
Yes.
So OY we can settle quite fast. So now I'll show you how we can find the length of a line lah. So if we plot it into a graph, right? Let's say we have a graph. So this is 0, right? And then 1, 2, 1, 2, 3, 4. This is O, and this will be W, right?
Yeah.
4 lah, right? So this is
Yeah.
the line here. Now you see, if I draw this, now I change color, I draw a black line. And then now I have a different color, light blue over here. So what does this triangle look like? Is it a special triangle?
Right angle triangle.
Right angle. Where is the right angle at? Near which number?
Said Z or 2.
Near the 2 there, right? So it's here lah, right? And then now we know that the blue line, the length is 2, right? And the black line, the height is what?
4.
4, correct? So so it's a right angle triangle, right? And we have 2 out of 3 of the lengths, right? So are we able to find OW now?
Yes.
Okay, what do we do now? OW equals to, or what? OW what?
Equals to 2 square plus 4 square.
So are you missing something? Is this the Pythagoras theorem? What is the Pythagoras theorem like in alphabets?
Is A square plus B square equals C square.
Okay, right? So compared to our equation, what are we missing?
C square.
The square lah, right? Oh, someone wrote the square. Okay, the OW square lah, right? But then we don't want OW square. What do we want? We only want OW, right?
Yeah.
So OW equals to square root 2 square plus 4 square, which is where this B square root 5 will come later lah. So one of these, the sum will give you square root 5. Okay?
Yeah.
So with 4 plus 16 equals to square root 20. So square root 20, if you remember in certs, do you think we can simplify this?
Yes.
Okay, how do we simplify it into? Elliot, do you remember how to simplify square root 20?
Square root 4 times square root 5
Okay, which is equals to?
to square root 5.
Okay, so now you see where we get our b square root 5 from lah, right?
Yeah.
So now we have OW and OY. So now that I taught you this length, how to determine the length using Pythagoras theorem, right? Can you try WX and YX?
Okay.
If you need, right, you can always like, cause now you're just starting, right? You can just draw like the graph, a mini graph on the side, like what I did, lor. So that it's easier to visualize how to do the Pythagoras.
Okay.
Are you okay?
I'm still thinking.
Okay. Which line are you doing now? WX or YX?
YX.
Okay, so just so what was the first thing I did just now on the graph? I plotted it out first, right?
Yeah.
Yeah. So how about you just plot a bit, lor, like write the number. So y is 5, right? So you just write until 5. Then x is 6. Then you just plot a bit, lor. Okay. So where is the right angle?
Here.
Yep. So now you see the right angle, right? So you are able to determine which is the like the length lah, right?
Yeah.
So then from there you're able to find the length, right, of the xy.
Yes.
I can move the paper a bit. Yep. Can, right? So now we have X, Y. So there's one more left to do, right?
Yeah.
Okay. WX, right? One. Oh, because you want to find that perimeter. Yes, of course, right? Okay. Okay. You remember how to simplify root 20?
Yeah.
No, very nice. Very nice. Okay.
Yep.
How about the OW and WX? The line like so different, but it's the same. The length is the same.
Remember, not up to scale. So this is the picture fooling us in a certain sense. That means the scale is never guaranteed there, which is to say the length is never guaranteed. Remember, 2 is here, but 5 is here. That's so not right. Remember? So not right. By right, 2 is nearer here. So I'll explain what's happening here. 2 is here, ma. If you look at it that way, OW has has greater possibility to be equal to Wx, if that makes some sense.
Yeah.
It is because the position of W, they purposely make it wrong. Purposely. Okay. Purposely.
Okay.
Okay. Can they do this? This one they can. So they can bluff the scale. A very good observation. Very good observation.
Oh, I'm done already.
All right, got it. Okay. Kakak Brian, I'll summarize. Yeah, I'll summarize. Okay. So you experience a lot of aspects of this graph just by 2 questions. I have a hope that the next question you try, a lot of things will look familiar already. I mean, basically, we went through 80% of the topic, basically. Okay, so hopefully when your teacher teach later, you also find it to be quite manageable. As you can tell, the marks are definitely greater than the previous chapters, isn't it?
Yeah.
This is easily total 8 to 10 marks, even though actually it is not that hard. If that is your impression, that will be correct. We take a lot of time to study binomial, but this one, not that long, not that long. We just have to practice a bit. Okay. Yeah. So next time we meet, it will be on Sunday. Am I correct? Sunday. So on Sunday, you won't have any much binomial, correct?
Yes.
I would like to give you a few CG questions. You give it a try, practice all these things. That is already like one big topic in term 3 done. So you are done with binomial. Hopefully, you can just practice, and you hopefully are done with CG also. Your term 3 should be rather stable that way. Okay. Good job, Elliot. So many times seeing you this week. I hope you can enjoy your holiday tomorrow, and I will see you on Sunday.
Thank you. Bye-bye.
Thank you very much, Kakak Brian.
Thank you, Kak.
Bye-bye.
Wait, so it's
Yes, Kakak Brian.
do I have to come or
Sorry, I cannot hear you. Sorry.
Sunday? Do you need me here?
Sunday should be normally packed already with additional. Well, we have 3 additional new students, right? All to Sunday lah. So I basically did a lot of rescheduling on the other days, but Sunday will always remain packed.
Okay.
So this Sunday, the 8:31 is the usual slot, right?
Yes.
Okay. Would you please, if it's possible for you, would you please stand by on, oh dear. Actually, what I want to say is please stand by on 6 p.m. But then again, the 6 p.m. one is mostly JC student. So never mind. Sorry, never mind. Never mind. The 6 p.m. was usually not crowded at all, and now it is quite crowded lah. But with 2 JC student and 1 secondary student, so correct, right? You're not very comfortable with JC stuff right now, am I correct?
Yeah. Like I wouldn't want to in case.
I understand. So anyway, let's stick to 8:30 to 10 first. The schedule should be the other day schedule should be confirmed by the week lah. Then we can be more certain. Right?
Yeah. Okay.
Thank you very much. I will see you.